A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to this another session of Indian Geography, where today we shall be moving ahead with a portion of physiographic divisions. Yesterday, in the terms of physiographic divisions and the location, we had covered the portion of the Himalayan region and the hills in the east. We had also covered the distinct features about the northern plains, its formation, what is the concept of 4D associated with it, what are the different features of the northern plains as you move progressively from the southern edge of the mountains into the northern plains progressively, where we observed the presence of a Bhabar tract, which is a kind of a rocky terrain, the rocky region, having a lot of large deposits of rocks and boulders. Then moving on to the marshy tract of the Tarai belt, and then you have the alluvial plains having the older and the newer alluvium also. The newer alluvium refers to or is known as the Khadar belt, and the region where you have the alluvium which got deposited a lot earlier, that is what is referred to as Bangar. Then after that, we looked into the aspect of the Thar desert. We understood that the region of Thar has not always been a desert. It has been created as a desert very recently. We also looked at the fact that in the geological history of that region has also lied underwater for some amount of time as the Indian plate was colliding with the Eurasian landmass. And as a result of that, and as a consequence of that, in fact, you will find the presence of crude oil deposits, natural gas formations in the region of the Thar Desert, particularly around the region around Bikaner, and also the presence of certain rocks such as limestone and marble. Marble is again a metamorphosed form of limestone, which again indicates that this particular area would have been underwater millions of years ago. So these are the factors that we have looked at. Today we shall be taking a look at few of the other physiographic divisions of the country, and then we shall be moving ahead into the drainage systems of the country. Okay. Now here, for the portion of your examination, what is relevant? So in the prelims, again, for the prelims, here, it will be relevant for you to be able to know about location of physiographic divisions. Then after that, also types of drainage, that is sequent and insequent streams. Then after that, drainage patterns. Okay. In the mains examination, you can expect questions such as lack of delta formation, in western coast, then after that, frequent landslides in Himalayas, as compared to Western Ghats. So these are the portions from which questions have been previously asked and the questions have been repeated in these areas. So that is where you can basically expect the derivation of questions in the mains examination also based upon your basic understanding of the physiography. You can have the conceptual questions being asked from this particular area. Now, when we move on and further into the drainage systems, when we talk about the river systems of India, then you will have another areas which are relevant for both prelims as well as for the mains exam. So, first of all, we start with the portion of the Peninsular Plateau. Now, when we talk about a plateau, plateau is what? Plateau is a kind of a flat table land like structure. So, whenever we talk about or come across a plateau, it is like a flat table land like structure that you come across. Okay. So that is the case of a plateau. So generally in the case of a plateau, you will find that the edges are still a bit steeper and the central portion can be having a flattish portion, can have the presence. Now, if let's suppose there is erosion, wind erosion, riverine erosion, etc., which is carried out, maybe it can have some indented hill-like features, etc., which might develop due to the factor of erosion. But again, the slopes will be having a kind of a slope gradient, or the edges will have a kind of a slope gradient. Now, these peninsular plateaus, or the peninsular plateau of the country, why it is peninsular plateau, known as the peninsular plateau? Because it is present across the entirety of the central and the southern part of the country. And that is a kind of a peninsular landmass. And peninsular landmass is the one where the land is surrounded by water from three sides. That is what is referred to as a peninsula, where the land is surrounded by water from three different sides. Now, here, in this case of a peninsular plateau, it is amongst the oldest rock formations across the planet and definitely the oldest rock formations when it comes to India. Now, they have been created as a result of the volcanic processes. Volcanic eruptions have happened multiple times in the past, and that has led to the formation of this plateau like region. Multiple different types of volcanic eruptions and multiple different events of subsequent volcanic eruptions, they have created deposits of lava. And those deposits of lava on top of each other, that is what has eventually created a very thick mass of igneous rocks. It is due to these igneous rocks where eventually, basically, you will find that many of these rocks, due to the overlying pressure of the newer volcanic matter, of the newer lava which has cooled down, that has basically led to the formation of even metamorphic rock systems in these peninsular plateau systems. But then, when we talk about this peninsular plateau, it is not as if the volcanic eruption has happened now or has happened recently. The volcanic eruption in these regions of peninsular plateau has taken place millions of years ago, and in many of the cases, billions of years ago. So that is why today you won't find the evidence of any active volcanism in that area, in the entirety of the Peninsular Plateau region. But then it has happened previously in multiple different iterations, and multiple subsequent eruptions have led to the deposits of this volcanic matter. Now, let's suppose multiple different volcanic eruptions have created layers of this lava and the lava rocks, multiple such volcanic eruptions. Now, over a period of time, the top rocks have basically witnessed so much amount of weathering, erosion, and other activities that basically, as the top portion has gotten eroded and removed due to weathering and erosion, the lower portions, which are rich in mineral deposits, those lower portions are now available very close to the surface. It is due to this reason that you will find that the region of Peninsular Plateau is extraordinarily rich in minerals, very, very significantly and substantially rich in mineral deposits. Okay, so rising from the height of 150 meter above the river plains up to an elevation of close to around 900 meter, is the irregular triangular plateau, which is known as the Peninsular Plateau. Now, it is one of the oldest landforms created on Earth and is definitely one of the oldest landforms in India. Now, the Peninsular region, which has got a volcanic origin, that underwent erosional and weathering activities for millions of years. Right. Now, due to this, the minerals lying deep inside the rocks can now be extracted, making the peninsular region very rich in terms of mineral deposit. This is the reason why you'll find that even in the peninsular plateau areas, the oldest ones amongst them, wherever you have the oldest of these structures, that is where weathering and erosion would have taken place for a very long period of time. It is in those areas where continuous weathering and erosion activities, they have exposed the underlying layers, and that is where the plateau formation has basically taken place. That is where you will find that the minerals have come very close to the surface. Now, when we talk about this entire stretch, when we talk about the extent of the peninsular plateau, it is the entire stretch from all this way here. Okay, this is the entire extent of the Peninsular Plateau, even including this portion. Meghalaya Plateau is also considered to be a part of the Peninsular Plateau. Why? Because the origin of the rocks, the property of the rocks is absolutely the same as is the case of the Peninsular Plateau, right? The property, the formation, the time period of the rock formation is almost the same. That is why Meghalaya Plateau is considered to be a part of this Peninsular Plateau system. Now here, it did not get created all at once. It is not the case that a volcanic eruption will create such a large landmass, that too at once. It got created in multiple different small steps and stages. Now, whenever you have creation of a volcanic eruption or existence of a volcanic eruption creating a newer landmass, it is always the case that smaller chunks of the landmass gets created. For example, when you take a look at the continent of Africa, do you think that the entirety of continent of Africa could have been created in one go? Is that possible? No. You cannot have such a large landmass getting created in one go. In fact, how these larger land masses are created is initially you have many of these smaller land masses which come into existence. Due to volcanic eruption, obviously, many of these land masses, they come into existence, right? And later on, these land masses, they will collide with each other and they will form a continuity, right? So eventually you will have a kind of a continuous landmass like this. So that is how slowly and steadily even the continent building takes place. That you have multiple chunks of these small land masses getting created simultaneously or one after the other. And over a span of multiple billions of years and also many hundreds of millions of years, they undergo collision, convergence, etc. They get together, and then you have the formation of a larger structure. Now, these building blocks of the land masses, that is what we refer to as cratons. Okay. So these individual land masses, which eventually become the building blocks of the larger continent or a larger land mass, that is a craton. So when we talk about a craton, building blocks of land masses, which come together, or building blocks of continents also you can think about, which come together to form larger continents. So, the building blocks of these continents, the small individual building blocks which contribute to the larger continent building, that is what is referred to as a craton. So just like that, even in the case of Peninsular Plateau is a region of multiple such cratons coming together and then constituting the larger landmass. So if we talk about the evolution of the Peninsular Plateau, you had few of these cratons which even initially got created. So the earliest of these cratons which got created were in the region around here, in the region of the Chota Nagpur Plateau. This was what was referred to as the Chota Nagpur Craton. At one point of time, it is said to have extended even up till the region of the Meghalayan Plateau. And at one point of time, this Chota Nagpur Plateau is said to have been extending in the present day area of Bangladesh and West Bengal also. It is a different matter altogether that due to the convergence of Indian plate with the Eurasian plate, that region of land underwent subsidence, but we'll take a look at it soon. So this was your Chota Nagpur Craton which got created. Chota Nagpur Craton. Then after that, you also had the formation of the Bastar Craton here. The region that we refer to as the Bastar Craton. The Bastar Craton also got created as a consequence, as a result of these volcanic activities. Then, for example, even in the region of Aravalis, you had the creation of the landmass. And as I told you, the Aravalis are old formations where they have been created as a result of folding. And you had the folding between the land masses and the continents of the ancient times, billions of years ago. And that is what led to the formation of the Aravali systems. These were also formed very, very earlier, Aravalis. Then you also had the creation of the Karnataka plateau. Karnataka plateau. You also had the formation of then the region of Bundelkhand plateau also, and the region of Bundelkhand also got created. Okay, so all these have been created a lot earlier. Now, it is basically, think about it, when you would have had these systems created billion years ago or a couple of billions of years ago, billion years ago, we are talking about a very long period of time, right? Billion years, think about it, that what a long time span we are talking about. Now, here, when you had this creation of these small cratons billions of years ago, as a consequence of that, you had multiple small rivers which would originate from these areas at that point of time. Multiple rivers would originate from these areas. They would be eroding these surfaces, right? They would be eroding these surfaces and they would be forming deposits all around. Here also, they would be forming these deposits. It would be the deposits of these sediments which would be created so that the land in between them would also get filled up with the sedimentary material. And those sedimentary materials eventually would also have multiple different forests, multiple different trees, vegetation also imbibed within them. The deposits of old forests, etc. That is also something that you find to happen in between these regions of these cratons. For example, in the region of Chota Nagpur Plateau, you have the movement of River Damodar. River Damodar also moves through a region of a rift valley. Now, there also you had the deposits of these older forests, etc. It is in these areas where all these forests, the old forests, were the sedimentation happened, the old forests, they got converted into coal. Over a period of hundreds of millions of years, these deposits which happened in between these plateaus, they got created into coal. Now, that is the Gondwana coal deposit that you find, that we will study in the portion of minerals and industries. The Gondwana coal deposits that you come across have been created as a consequence of this. Now here, you will also come across a scenario where, for example, many of these cratons, eventually many of these individual plateaus, they came together. Many of them, they collided and led to the formation of few of the hill formations and mountain formations. But many of the hills and the hills in these areas which you observe, they are an outcome of the volcanic process only. A very long, or a kind of a volcanic process which happened a very long time back, and in ancient times, that volcanic process created these hills. For example, in this area across the Eastern Ghats, the hill features that you observe, now these hill features have been created such a long time back, and they had volcanic origin and the volcanic formations of them, leading to the creation of these hills across the coastline of the Eastern Ghats, etc. Having said that, slowly and steadily, you had the coming together of the land masses due to deposition, due to fresh volcanic eruption, and you had a larger landmass which got created. A larger landmass got created as a confluence, as a result of the confluence of all these. And that larger landmass would be extending even in the area around Meghalaya, the present day region of Bangladesh, the region of West Bengal. In that entire region, a larger landmass got created. This was the shape of the Indian subcontinent, roughly the shape of the Indian subcontinent, which started moving away from the Gondwana land. Okay, when we talk about that Indian landmass started moving away from Gondwana land, roughly this was the shape. And yes, you had sedimentary plains created in the vicinity of it, obviously because of the rivers generating that amount of sedimentary deposit, and you had that sedimentary plains created all around it. But that is it, right? This was the kind of the Indian landmass. Now, as it started moving northwards, it came across the region of a volcanic hotspot. That volcanic hotspot, what we refer to as the Reunion Islands. So, if you think about it here, if let's suppose this is the planet, and here, let's suppose the Indian landmass, it started separating from the region of the Gondwana land, and it started moving northwards, right? As it came over here, over the region of southern Indian Ocean, you have the Reunion Island volcanic hotspot. Now, that Reunion Island volcanic hotspot meant significant eruption of volcanoes here, a substantial and a significant eruption of volcanoes here. And those volcanic materials, they actually spread over. Now, the Reunion Island volcanic hotspot, I hope we are aware when we had studied it in the portion of geomorphology. We had taken a look at the volcanic hotspots and we had talked about the fact that these hotspots, they tend to remain active for millions and millions of years. So it was around 90 million years back when the western portion of the Indian landmass lied directly over the region of these Reunion Islands. And that is when these Reunion Islands went for significant amount of eruption, continuous eruption. In fact, the estimates indicate that at that point of time, the Reunion Island hotspot in itself was accountable for more than 1.5 lakh kilometer cube of flood basalt or basaltic lava which spread over, okay, which came over that area. Now, basaltic lava, does it flow easily or is it very viscous? Do we recall anything about basaltic lava? Does it flow easily or is it very viscous and doesn't flow easily? What do we think? Good. Rohit, Chandrajyoti, Satyam, and Animesh, Akhilesh, Rishika. Correct. Basically, when you have these volcanic or whenever you have the basaltic lava, it tends to flow very easily like a liquid, right? That is why it tends to spread very, very easily. Always. You have the felsic magma, which doesn't, which is very viscous, which doesn't spread easily well, but basaltic lava spreads very easily and almost flows like water. Now, here, over a period of multiple millions of years, now understand it is not as if Indian plate was moving like a bus. You had an eruption and the Indian plate passed over it. No, it lied over that region for some amount of time as this eruption continued to happen around 90 million years back. Now, these eruptions, they would happen every 100,000 years, every million years, and every more 500,000 years, and so on. Whenever these eruptions would happen, the molten materials would start spreading around. And the molten materials, they start spreading around this entirety of the area. In this entirety of the region, the molten materials, they start spreading around. In this entirety of the region, these molten materials, they started spreading around. And each of these layers of lava, they were differentiated from each other over a period of hundreds of thousands of years. So let's suppose you had the eruption, and that eruption basically created a kind of a large shield-like feature, the shield volcanoes. Remember that we had studied the shield volcanoes? So basically, it spread over a very large extent. Now, again, this remained for some substantial amount of time. Again, you had fresh eruptions, again, creating a kind of a flood basalt, which would spread over a large area. Again, it would stay consistent for a long time. Again, you would have a presence of a large volcanic eruption, which would spread the materials. So, like this, you had many such subsequent eruptions, thickening this area, okay, thickening this entire Deccan region. Now, when taken a look from the sides, when observed from the sides, these tend to form a kind of a step-like feature. And that is what we refer to as, that is what is referred to as trepen, right? The step-like feature which is formed on the sides. Step-like feature that you find to be present on the sides. That is what is referred to as trepen. And it is from this that you have the derivation of the term traps. So that is why this entire region is what is referred to as Deccan traps. These Deccan traps have been formed as a result of multiple deposits of flood basalt. Why it is referred to as flood? That is because it spreads like a very significantly superfluous fluid. It spreads over a large area. It appears as if it has flooded the region. That is why flood basalt. Now, in between all of these layers, you would have various different areas of water which would be trapped. Because think about it, that an eruption would occur, it would cool down, it would stay like this for maybe a couple of millions of years, and again another eruption would happen, or it would stay like this for, let's suppose, 500,000 years, and again it would spread over. So that is how, think about it, 500,000 years is such a long period of time. If you reverse the clock back to 500,000 years from today, we are basically looking at a world which was very different. Humans, as we know today, had not even evolved to that extent. So that is why it was in that duration that you had, for example, layers of water which would be formed, and they would then be trapped by another kind of a volcanic eruption. That is why even today, when we talk about the Deccan traps, these Deccan traps are so very thick. In many areas, these, excuse me, in many of these areas, you would find that so much amount of lava has spread over that the thickness of lava rocks or the volcanic rocks in this area, for example, in western part of Maharashtra, the thickness of these volcanic rocks is around 15 kilometers. So you can always imagine what kind of eruption would have taken place, how humongous an eruption would have taken place. The planet has not witnessed that kind of humongous eruption for the past 90 million years. So that tells you that the volcanism at that point of time was very significant. But then Indian landmass started moving northwards. And then again, there was no such volcanic eruption which happened ever after in the entirety of the Peninsular Plateau. That was one of the last phases of massive volcanic eruptions which happened. That is why Deccan traps today you will find multiple such layering, and Deccan traps in today's day and age, you will find that within these layers you have some minerals which get trapped, some uh, water which gets trapped. Right now, it is these basaltic rocks which are darker in appearance, which have a higher density. Basaltic rocks generally rich in iron, magnesium kind of materials. Now they are darker in appearance, higher in density. These basaltic rocks, the flood basaltic rocks, when they weather down, when they disintegrate, that is when they lead to black soil formation. Okay, so that basaltic rocks, when they disintegrate, that is what leads to the black soil formation. Okay, weathering of this basalt, weathering leads to black soil formations. So that is why in this region of Deccan traps, spreading even in the area of the Malwa plateau in the portion of Madhya Pradesh ever so slightly, that is why this is a region of black soil. Okay, and in these areas, the volcanic rocks, they have disintegrated to form the soil, which is again formed from the rocks which have volcanic origin. That is the red and yellow soil. When we come to the portion of soil and the distribution of the different types of soil across the country, you'll find the presence of red soil formations in all these areas, black soil formation in these areas. Now that is to do with the origin of these places, the origin of these particular areas. Okay, that is how slowly and steadily the entire region got created. Having said that, the Indian landmass was much more wider in this area, was much more wider in this area, okay, and also consisted of the landmass here. But then what happened? So basically, as the Indian landmass basically got underwent collision, as the Indian landmass underwent collision with the Eurasian plate. Let's suppose we talk about the Peninsula Plateau system. As the Indian landmass of those times underwent collision, you had collision between massive continental areas. Obviously, it is not going to be a soft collision. Obviously, it is not going to be without any consequences. When two solid objects create so much amount, when two solid objects collide, so much amount of impact is created. So you can think about it that continental land masses are colliding. The impact would have been humongous. That is when cracks develop and fault lines developed. You had a significant fault line which developed here across the western coast. You also had a fault line which got created here in this area. Okay. And because of the creation of this fault line, eventually, as the further collision happened, folding happened, these areas they became loose and they underwent subsidence. We have seen in the case of a normal fault also that the regions undergo subsidence, right? So these areas underwent subsidence. That is the reason why in this particular area you find that there is a discontinuity between the Peninsula Plateau region. There is a kind of a discontinuity which does exist. Okay. Now, in this region, as the land underwent subsidence, immediately that created a gap in between the region of the Chota Nagpur Plateau up till the Rajmahal Hills to the east, and here between the Meghalaya Plateau, which at one point of time was very much a part of this Peninsular Plateau system. And here, this landmass underwent subsidence here, creating the wide continental shelf that you see across the western coast. This creation of a gap that allowed the rivers, the Indo-Brahm rivers, which had already come into existence for a few 100,000 years, that had started depositing materials in the region of the present-day northern plains. Now, those rivers of Ganga, Brahmaputra, etc., all of them, they found a way of exit towards Bay of Bengal. Now, all the rivers, they started draining in from this area. All the rivers, they started draining from this area. That is why you will find even in the case of River Ganga takes a southern turn immediately after the Rajmahal Hills, because there was that creation of a gap which allowed for the passage or the movement of the river. So that is basically where you had a kind of depositional feature which started getting created. That depositional feature is, in today's day and age, what is known as the lower Ganga plain, that is the Rad plains, and also the region of Bangladesh that you see, the region of West Bengal that you see. They have been created as a result of these deposits. Okay, multiple of these deposits by these rivers have taken place. That is why the region of Bangladesh and the region of West Bengal you'll find having very fertile alluvial soil. It was not always the case that you had alluvial soil there. You had the plateau region, but that plateau region underwent subsidence, creating a large gap. So that large gap which got created here, that is what is also referred to as basically the Rajmahal Garo gap. Rajmahal Garo gap or Malda gap, because to be this gap is found to be present or initiating around the district of Malda in West Bengal. That is the region of Rajmahal Garo Gap or the Malda Gap. So the Malda Gap basically provides the differentiation between the Chota Nagpur Plateau here and the Meghalaya, the Karbi Anglong and the Shillong Plateau to the east. While in this portion, as the land underwent subsidence, that is what created a vertical wall-like formation across the region of the Western Ghats, because the western coastline was not always like this. The western coastline was very much having a kind of a feature like this. Okay, but as the land simply underwent subsidence, what was left behind was a steep wall-like feature that is still present and prevalent today. That is why Western Ghats are very erect and very straightforward and almost vertical. It is why this is the reason why Western Ghats, they are also known as an escarpment. An escarpment gets created when you have, in the case of a normal fault, one particular portion which undergoes subsidence, the other portion remains upwards. That is an escarpment that we have studied. So that is the reason why Western Ghats are not known as mountains. They are known as escarpments. And this is the reason why across the western coastline of India, you have much wider a continental shelf as compared to the eastern coastline. Now, when the Peninsular Plateau was created, when you had the Deccan Traps getting created, and the Indian plate was still moving northwards. Now, at that point of time, you had multiple such events and phases of volcanism. Now, after a point of time, the volcanic materials, they found it incredibly difficult to break through the surface. They found it very difficult because on the surface you had so much thick deposit, kilometers thick deposit of igneous rock formations already. So the volcanic materials, they found it almost impossible to break through the surface. So these volcanic materials, because it is a region of a volcanic hotspot, the Reunion Island is a region of a volcanic hotspot. It will continue to have the eruptions even today. The region of Reunion Island is very active in terms of volcanic eruptions. So think about it. If basically here, this is the western portion, this is the eastern portion, this is the portion which experienced volcanism. So here you have the rocks which are so very thick and dense. Newer materials, they are unable to come out. But the Reunion Island hotspot is pushing more materials, more molten materials into this area. So what would happen? Here, basically, as more materials would try to come up, eventually, this would not be able to break through the surface, but start solidifying in this area. The molten materials, they started spreading underneath the region of the Indian plate and they started pushing it up. This is the reason why even today in the region of the Peninsular Plateau, you'll find that the general slope of the land is from west to east. And that general slope from west to east is a resultant of that volcanic activity which has pushed this landmass ever so slightly upwards. Okay, so that is the case of the entirety of the formation of Peninsular Plateau. In fact, just an additional bit of information for you. It was during this particular moment where you had significant amount of eruptions which wanted to come up to the surface but could not. That is when many of these molten materials, they spread underneath the Indian plate. And these molten materials, when they spread underneath the Indian plate, that acted as a kind of, in a very simplistic of the terms, that acted as a kind of a lubricant of sorts, which further accelerated the rate of the Indian plate motion. That is why when we had talked about the formation of the Himalayas, we had talked about the fact that Indian plate was moving at a very high speed, around 15 to 20 centimeter per year. Now that additional speed was provided by the spread of these molten materials inside the Indian plate, and it accelerated to the north. That acceleration eventually was the one which caused the collision, and eventually that speed slowed down only after the Himalayan collision happened. So this is basically the entire formation of the region of Peninsular Plateau. That is why today, when we talk about the mineral deposits of the country, majority of the minerals that you will find it in the oldest portions of the Peninsular Plateau. So which are the oldest portions of the Peninsular Plateau? Chota Nagpur region, Jharkhand, Odisha, parts of western part of West Bengal, Chhattisgarh, then the region of Bastar Plateau, that is the region around Chhattisgarh, adjoining areas of eastern Maharashtra, some parts of Telangana, and also parts of Odisha. Then Karnataka, there you will find the presence of minerals. So these are the older areas. Aravali's very old area. That is also where you will find iron deposits, right? Then Bundelkhand region also rich in minerals. But you won't find many minerals in the region of the Deccan Traps. And that is because these Deccan Traps, they have created multiple such layer of volcanic rocks above the pre-existing landmass. Okay, then These you won't find many minerals, let's suppose, in the plains. Why? Because they have been created due to sedimentary deposits quite recently after the formation of a 4D. So this is the source of, if you want to understand the mineral deposits of the country. I have seen many candidates trying to mug it up, trying to rectify for every mineral. Okay, this is to be found in Jharkhand, Odisha, Chhattisgarh, Karnataka, Jharkhand, Odisha, Chhattisgarh, Karnataka. Never have they asked that question to themselves, why only Jharkhand, Chhattisgarh, Odisha, and Karnataka? Why not in the region of Uttar Pradesh? Why not in the region of Gujarat? Right? So that is because these were the oldest of them. Now, in fact, when the Indian landmass, they underwent collision here, basically, when the Indian landmass underwent collision, you had this region of Run of Kutch, etc., that you see. That also formed a part of the continental shelf. Multiple such rise and fall of the sea levels that has created the region of Run of Kutch, which at one point of time, the region of Gujarat that you see, other than the Gir ranges, the region of Gujarat was very much underwater. And subsequent sedimentation by the rivers originating from the Aravalis, they have created the region of the Gujarat plains also. And because it was underwater, which kind of mineral or which kind of resource can be found there? Crude oil. That is where Ankleshwar oil fields, etc. These are the regions of crude oil exploration in Gujarat. That is why even today oil is extracted from the Bombay High region to the west coast of India. So that is why if you know the genesis or the formation, see, UPSC is not going to ask you a question that talk about the origin of the Peninsular Plateau. No. But UPSC has asked last year, talk about the features of the Deccan Traps and discuss the features of the Deccan Traps. It was asked in the mains examination. Now, if you know the process of formation, you can very easily be able to enrich and depict your answer. Majority of the candidates, you will find they study the basic books or the reference materials. There, all they come to know about is that the Deccan Traps are created by this volcanic eruption. That's it. But from where? For how long? What is the feature? In between these rocks, you have the water and few of the other minerals which are trapped. It is the weathering and erosion of these rocks which has created that region into a black soil area. Okay, so that is, those kind of questions are always asked in the case of the examination. And mineral deposit, soil distribution in the country, accordingly, the topographical variation of the country can all be well explained if you know the origin of these landmass. So this is clearly one of the oldest landmasses of the country, and possibly few of them can also end up forming the oldest landmasses of the world, because research papers have indicated. You had a research paper which was submitted in late 2021, early 2022, which found out that in the Singhbhum region of Jharkhand here, there were evidences amongst the rocks, there were evidences of sandy beaches. That the rock formations indicate that at one point of time, these would have been the sand across the beaches, which eventually solidified to form the rocks. Okay, so that means it would at one point of time would have been an individual island-like landmass, which would have been surrounded by water from all sides. Okay, and when we talk even about coal deposits also, when you find in the region of the Godavari, the Mahanadi, and for example the Damodar river valleys. Now these have been created at that point of time around 200 to 50 million years ago, and even before that, when you had basically the sedimentary formations in between these cratons or in the rift valleys in between them taking place. And that is when you had the old plants, many of these older forests, ancient forests which got deposited there over a period of hundreds of billions of years. They have carbonified to form coal. That is why you don't find coal in these areas, do you? You find coal in these particular regions. Okay? Now, when we talk about the extent of the Peninsula Plateau, what is the extent of the Peninsula Plateau? It extends from the Delhi Ridge in the northwest. That is the entire region of, to the west part of Delhi, you have the Delhi Ridge, which is considered to be the extension of Aravalis. At one point of time, this Delhi Ridge is, or the Aravalis, as we discussed yesterday, would be extending all the way to the region of Haridwar. But now you don't have that extension of the Aravalis anymore. So the Delhi Ridge in the northwest, Rajmahal Hills. Where are the Rajmahal Hills? This is the region where you have the Rajmahal Hills. That is where, beyond the Rajmahal Hills, you have the Malda Gap or the Rajmahal Garo Gap, where River Ganga takes a sudden southward bend. Now, here, that Rajmahal Hills in the east, Gir Ranges in the west, Cardamom Hills in the south, and even Shillong and Karbi Anglong Plateau was considered to be an extension of Peninsular Plateau. So this is the extent of the Peninsular Plateau. Now, overall classification of the Peninsular Plateau, if you do, it can be divided into three broader classifications. You have the Deccan Plateau, which does include the Karnataka Plateau also, does include the Telangana Plateau also, does include the Deccan Traps also. So that is all inclusive in the larger Deccan Plateau. Then you have the Central Highlands, that is in the region of Bundelkhand, Malwa Plateau, Baghelkhand in the region of Madhya Pradesh and Chhattisgarh. This is the area of Baghelkhand. Okay. And also, here you eventually had the formation of the Vindhyas and the Satpuras due to faulting processes, creation of horst and block mountains. So that is where you had basically the region of the Central Highlands will be included in that, and the Northeastern Plateau, including the Shillong and the Karbi Anglong region. So this would include the region of Bundelkhand. This would include the region of Gujarat region was underwater, then how it came up to the land surface? If you recall, in the portion of geomorphology, we had discussed that due to endogenic forces, due to various different endogenic processes, multiple times the land gets uplifted, gets subsided. In the region of Gujarat, you also had, over a period of hundreds of millions of years, we have come across multiple such events of rise of sea level, fall of sea level, and you also had the rivers originating from the river region of Aravalis. They also would carry out substantial amount of sedimentary deposits. So all these features combined together basically made the land, or the present region of Gujarat, which appears to be above sea water. That was not always the case. Okay. For example, in 1819 or in the 1810 decades, you had a massive earthquake in the region of Gujarat, and during that earthquake, as the readjustment of rocks would have happened in the interior, a portion of land simply sunk down. But simultaneously, you had a large portion of land which emerged above water because of the readjustment of the rocks. So, multiple such events do take place, due to which the areas which have traditionally been underwater, that rises up, and the areas which are above water goes down. So that happens. For example, if you talk about the eastern coastline of India is referred to as an emergent coast. Emergent coast because that is the region which slowly and steadily has risen slightly above, and the fall of seawater has also led to the rise of the land, exposing many portions of the land above water. That is why, even across the eastern coast, you will find the presence of crude oil, particularly around the Krishna Godavari basin. You will find the presence of crude oil there. Okay, so that is why eastern coastline is known as an emergent coast, whereas the western coastline is known as a submergent coast, because across the western coast, submergence has happened. So it is here where you have Bundelkhand in the Central Highlands, Malwa Plateau, Central Uplands, what is also referred to as the Madhya Bharat Pathar in the region around Gwalior, Guna. Then you also have Baghelkhand, then Vindhyas, and Satpura. Deccan Plateau would consist of the Deccan Traps, it would consist of the Karnataka Plateau or the Dharwad Plateau as it is also known as it, Telangana Plateau. These would be included in that. So, Karnataka Plateau, then, for example, we talk about the presence of Telangana Plateau. Then, for example, even the presence of Deccan Traps. And here, the northeast, we are talking about Shillong and Karbi Anglong Plateau. So here, ideally, you should know about the location of these. That is sometimes asked in the prelims in terms of the states where they are present. You had a question which was asked earlier about the state in which Baghelkhand is present. Okay, so that is present in the region of Madhya Pradesh. So here, if you take a look at it, then always you can basically approach the atlas, take a look at the atlas, and that will give you an idea about the respective location also. For example, the Aravalis. The Aravalis are situated here. Okay. At one point of time, it would extend up till Delhi and further up till Haridwar. That is the Delhi Ridge. Here is where you have the Shillong Karbi Anglong Plateau. Then here is where you will have the Chota Nagpur Plateau roughly. Here is to the edge of Chota Nagpur Plateau is where you will have the Raj Mahal Hills. These will be your Raj Mahal Hills. Okay. Now, here is where you will have the Bastar Plateau. It is in between the Chota Nagpur and the Bastar Plateau, where in Odisha you will also find the presence of Garjat Hills. Okay. Then you will find the ever looming presence of Vindhyas and Satpura here. In between the Vindhyas and Satpuras, you have the Rift Valley through which river Narmada flows. River Narmada drains through that area. Now here you will have the presence of the black soil region of the Malwa Plateau. This is where you will have the presence of the Malwa Plateau spreading across Madhya Pradesh chiefly. Okay, then you will have Bundelkhand region spreading across Madhya Pradesh and also parts of uh, Uttar Pradesh. There also you will have the region of Bundelkhand. Adjoining it will be the region of Baghelkhand, spreading mostly in Madhya Pradesh, but some part of it in Chhattisgarh also. That will be the region of Baghelkhand. Here you will find the central uplands in this area to the north of Bundelkhand. Then, for example, here you will find the region of the Deccan Traps spreading across southern Gujarat, parts of Madhya Pradesh, okay, parts of Telangana, parts of northern Karnataka, and obviously ever looming presence in Maharashtra. This is the region of Deccan Traps. Here you will find the presence of Telangana Plateau in this area, Telangana Plateau. Here is where you will find the presence of Karnataka Plateau. Okay. In between, you will have Kaimur Hills here, Ramgarh, Hazaribagh Plateau, then Gavilgarh, Satmala Ranges, all of that you'll find in this area. So, this is the formation, the detailing, the features, the naming of the Peninsular Plateau system. We have taken a look at why the Peninsular Plateau system is so rich in minerals, why the Peninsular Plateau system basically is so very old, why the Peninsular Plateau system has got a kind of a gap between the Chota Nagpur and the region of Shillong and Karbi Anglong, why their general slope is between from west to east, why the western coast has got a larger continental shelf as compared to the eastern coast because the land has subsided there. We have taken a look at within the Peninsular Plateau, which are the mineral rich areas, the older portions of it. We have tried to understand the reason why you have different types of soil formations in the different regions of the Peninsular Plateau. So these are the detailings that are relevant for the portion of your examination. Okay. Now, after this, we come to the portion of the eastern and the western Ghats. Now, as I told you, when we talk about the plateau, plateau will have its edges. Plateau will have its edges. Sham, the cratons can be formed by any kind of lava, mostly felsic, but any kind of lava can lead to the formation of craton, but mostly it is felsic. So here, when we take a look at the plateau system, on the edges here, you'll find some kind of a steepness. Now, we do know that in the case of the Peninsular Plateau, the general slope of the land is from west to east. That is why majority of the rivers, they originate close to the Western Ghats, but they flow all the way to the east and drain into the Arabian Sea. But when we talk about the Eastern Ghats, the region of the eastern coastline, that is referred to as to be an emergent coastline. It has emerged above water in the past, right? The land has slightly emerged up, and that is largely because there was so much amount of volcanic eruption happening on the other side. It created a kind of an imbalance, but also the consecutive rise and fall of sea level during multiple ice ages and the interglacial period have also supported the rise of land. So, in the eastern portion, the land has slightly risen upward from underwater. In the western coast, you have had the land which underwent subsidence. Now, when we talk about the western coast and the eastern coast, or the western Ghats and the eastern Ghats, which has been created earlier, what do you think? Which got created earlier, the eastern Ghats or the western Ghats? Obviously, very good. Always the eastern Ghats that got created billions of years ago. So as these eastern Ghats, they got created billions of years ago, western Ghats, the western portion, you had volcanic eruption as late as around 90 million years back. So western Ghats got created much later. So that is why in the region of the Eastern Ghats, you will find that it is not continuous. It has been heavily eroded, it has been heavily weathered, and you have flow of multiple rivers from the region of, let's suppose, if you talk about Mahanadi, Krishna, Kaveri, Godavari, all these larger rivers you will find, they end up creating a gap in the Eastern Ghats. So the Eastern Ghats, they are not at all continuous. But when we talk about the Western Ghats, that has been created much more recently. So the Western Ghats, they will be much more continuous. The Western Ghats, they will be much more continuous. Right. Now, you will also find that the Western Ghats region basically is not only continuous but has got a kind of an escarpment like feature, a steep wall like feature on the sides. And why is that created? Because as the Indian plate was converging with the Eurasian landmass, there was a development of a fault and that led to the submergence of the landmass nearby. So when we talk about the region of the Western Ghats, for example, so the shape at one point of time would have been very similar to this. Okay. Basically, even across the western coastline or the western portion, you would have a bit gentler slope. But then, during that collision, during that convergence, the portion here developed a kind of a crack. A normal fault was created, and this portion underwent subsidence. This is your west, this is your east. This portion underwent subsidence. As it underwent subsidence, the resultant landmass was somewhat like this. Okay. Let's suppose this is the water. This was the resultant landmass which got created, and here you had the landmass which underwent subsidence. This formed a part of the continental shelf. This is the reason why, despite the fact that the coastal areas in the west have a steep wall like formation, still, unlike the region of Chile and Peru, here you will find that the continental shelf is much wider. Because we have seen in oceanography also that the normal sense of logic tells us that if the coastline is having a steep formation or a steep feature, the continental shelf is not very wide. But here the continental shelf is still very wide. Why? That is because here the land mass has undergone subsidence, undergone the process of subsidence. Now, this is the continental shelf across western coast. Now, furthermore, if we develop on this particular concept, if you take a look at the depth of water immediately closer to the coastline, both in the eastern and the western coast, you'll find that water is substantially deeper closer to the coastline in the western coast as compared to the eastern coastline. Eastern coastline, the slope is very gradual, and the portion has also emerged above water in history. So that is why here the depth of the water immediately closer to the coast is not very high. But in the western coast, the depth is significantly slightly larger. Now, if in the coastline, if you have deeper waters immediately at the coastline, is it good for building ports or harbors? Or is it not good? If the water is very deep, closer to the coastline, can ports and harbors be present there? Or do you need shallower waters in the region for building ports and harbors? Okay. So, ideally, when we talk about ports and harbors are for what? It is not a sea beach where you can chill out with a kind of an easy armchair that, okay, I can go into the sea. Ports and harbors, they are basically where the large ships come. And if you ever would have seen a large ship, it has got a substantial portion of its body underwater. So when we talk about a large ship, let's suppose a large ship, a very, very large ship, it will have substantial amount of its body underwater also, right? So wherever you have deeper waters, that is ideal for the ship, for the construction of ports, and natural ports and harbors are situated there. Why? Because the ships can come at the coast, almost at the coastal area. But if you talk about the shallower areas, here the larger ships won't be able to come closer to the coast, right? Because it will run aground. That is the reason why Western Ghats or the Western coastline is ideally suited for the construction of ports and harbors. Natural ports and natural conditions for harbors are to be present across the Western coastline. Whereas when we talk about the Eastern coastline, you have ports which are present there. Right. I have students immediately when I say this, immediately they start saying, but what are you saying? You have Paradeep, Vishakhapatnam port. I have seen Vishakhapatnam port yesterday or previous year. I went with my family to see the Vishakhapatnam. You have these ports across the eastern coastline also, but their majority of them, for the construction of the ports, you have to dig it out. You have to dig out the region or the sand underneath to create a deeper water so that the ships can come further inland. I hope we are aware that none of the Indian ports as of now have the capacity to handle the largest ships of the world, what is referred to as the Panamax class of the ships, which are ultra large carrier container ships, very, very large container ships. Why? Because when you talk about very large and bulky ships, they will have a substantial amount of its body weight underwater also. And none of the ports in our coastline have that depth, right? So majority of the large ships you will find, they go to the Colombo port. And then from there, materials are loaded onto the smaller ships and then they come to JNPT, Kamarajar, Chennai, etc. None of the large ships are able to enter India. Having said that, in the region here, in this area around Tiruvananthapuram, you have the region of Virinium. Virinium port is being constructed with the help of so the state government had awarded the contract to Adani. So Adani's, they are constructing basically a deep water port here. It is going to be the first port where the water depth immediately closer to the coastline is going to be around 20 to 22 meters deep, which is much higher as compared to any of the ports that India presently has. Naturally, Virinium is that area where the water immediately closer to the coastline can be 20 to 22 meters deep. Even Colombo port, where the larger ships go, they have a depth of around 15 meters. That is why the government, the state government, the central government has been so significantly determined to construct that Virinium port. It met with a lot of protests that basically the private companies are there to loot us and they are going to destroy the ecosystem. But that Virinium port, once it becomes fully operational, some portion of it was inaugurated some time back, but once it becomes fully operational, that has got the potential to change the entire economy of the area, the entire trade paradigm of the region, because now India can host the largest of the container ships if that comes into place. And that India can serve as a transshipment hub where larger ships can come, they can basically berth here. And then after that, smaller ships can carry those materials. They can be supplied to rest of Asia also. That is where Virinium port has got so much amount of potential, and that is why, despite all the vicious or the significantly longer protests which were carried out, still Virinium port is undergoing or is given the green flag. Okay, so this is basically about the eastern and the western Ghats, right? And after that, no, JNPT doesn't have the capacity to handle the largest of the ships. Okay. And that is why when you ever go to the coastal area, closer to the beaches, etc., you'll find that the ships are anchored very far away from the coast. With the help of binoculars, maybe you will be able to see the ships. Why? They don't come closer to the coast because the water is shallow and the ships have the danger of running aground. They have the danger of getting stuck in that sand. Remember what happened a couple of years back in the region of Suez last year when you had a large ship getting trapped in the region of Suez Canal. Why did that happen? Because the ship basically veered off due to the heavy winds, etc. It veered off and it got stuck in the sand. And then you cannot dislodge it because you're talking about tons, thousands, and millions of tons of steel getting stuck in the sand to a depth. You cannot then simply pick up the boat like this and realign it and then again introduce into the water like you do in the small toys. And it stuck. It basically interrupted the global sea trade and the global sea traffic for months to come. Right. So that is basically the reason why the western coastline is much ideally suited for the construction of ports and harbors. Okay. Now, no, Indian rock system, that is the Gondwana rock, the Purana rock, the Archean rock system, the Aryan rock system, not very much relevant for your GS. It is relevant for your portion of the optional part. Even in optional, that detailing is not asked anymore, but it is not very important for your GS. Okay. Now, here, then we come to the detailing of it. So, Western Ghats that demarcates the westernmost extent of the Peninsular Plateau. It forms an escarpment on its western slopes due to the formation of a fault line and the region which has underwent subsidence, thereby being able to influence rainfall across the western coast. Because of that formation of escarpment, you will find that the western coast here or the western ghats, they have a steep wall like formation. So any wind which is coming here, that wind will be almost vertically lifted upwards. And that is where here you will find significant cloud formation, lot of rainfall to be occurring in this area. Now, it was formed due to submergence of a part of land into the sea. Now, Western Ghats are locally known by different names. For example, in the region of Maharashtra, they are known by the name Sahyadris, then Nilgiri Hills in Karnataka and Tamil Nadu, Anamalai and Cardamom in the region of Kerala. They are comparatively higher in elevation and more continuous than the Eastern Ghats. Why? Because they have been formed much more recently. Eastern Ghats, the formation has been ever since, for example, the Bundelkhand, the Chota Nagpur cratons, etc., they came into existence. The Karnataka plateau, etc., they came into existence, the Telangana plateau. Ever since that point of time, you had the features of the Eastern Ghats. But western portion, the entirety of the landmass was further reinvigorated, was further recreated when you had the eruption at the Reunion Islands around 90 million years back. So that is why Western Ghats, because it is much newer, Western Ghats is more continuous, whereas Eastern Ghats, because it is much more older, that is why it has been basically crisscrossed by the rivers and is discontinuous. Okay. Now, then the Eastern Ghats, basically, the Eastern Ghats run from North Odisha to Andhra Pradesh to Tamil Nadu in the south, passing through some parts of Karnataka. They are eroded and cut down through the four major rivers of peninsular India: Godavari, Mahanadi, Krishna, Kaveri. And you have some of the older ranges here: Javadi, Palakonda, then Nalamala Hills, then Chevroy. All these are amongst the older hills which have been created long time back. Okay. Now, it has not always been the case that the slope has been from the west to east. That slope from west to east has been created when? Again, at the time of the Reunion Islands, when the Reunion Islands was erupting and Indian plate was above that. It was at that point of time when you had the uh, thick igneous lava rocks and you had more molten materials which tried to come up but could not. And that is what created that kind of a slope from west to east, right? So eastern and the western ghats meet each other at the region of the Nilgiris. Now, after that, we come to the coastal plains. Now, both across the eastern and the western coastline, you have a wide coastal plain area. Now, coastal plains are always formed as a result of deposits, always. As a result of the depositional feature is why we observe the formation of plain areas at all. Now, when we talk about the eastern coastal plains, they are much wider. Why? because majority of the rivers, they drain into the region of the east, from west to east, because the slope of the land is from west to east. So that is why majority of the rivers will carry out their deposition across the eastern coastal plain. Whereas the western coastal plain is not so extensively developed because of the formation of that escarpment, as the land simply underwent subsidence, the formation of an escarpment, right? And that is why here the western coastal plain is very narrow. Historically, if you have read the portion of history, I'm sure all of you would have attended history by classes by now. All of you would have read history by now. I'm talking about the ancient and medieval history. You would have read that the kingdoms, they always vied for the control of the eastern coastline, because that was significantly very fertile land. For example, the mighty Cholas. Why do you think the Cholas were so very mighty? Is it because they had some of the blessing from gods themselves, that made them so mighty? No. Cholas had a massive revenue system. They could basically grow multiple crops in the same year, which at that point of time was not very common, was not very consistent. So, across the eastern coastal plains, the Cholas would basically control the eastern coastal. I'm not asking the name of the Chola rulers. I'm asking why they were mighty. So basically, they control the eastern coastal plain. And because they would control the eastern coastal plain, what would that mean? That basically would mean that, for example, what was the capital city? Urayur of the early Cholas, the Urayur which was on the banks of river Kaveri. Now, these were the regions where cotton was also grown multiple times. Rice could be grown multiple times in the same year. When you have that high in agricultural productivity, you will have a greater revenue system. When you have a greater and a robust revenue system, always you will be having a more amount of money to build your armed forces also. Throughout the pages of history, you'll find that those kingdoms have thrived, those civilizations have thrived, which have had a higher agricultural productivity. Take a look at the Byzantines. The Byzantines, the mighty Byzantines, they could become mighty, they could become the successors of the ancient Romans because of that system of agriculture taking over. The very reason why the Khiljis, they paid so much attention to agricultural reforms, because they were very much aware that if agricultural productivity is not there, you can never have enough revenue to build your armed forces at all. Right? So that is why the Delhi Sultanate, they basically focused in the region of the Doabs, between Ganga and Yamuna, how to increase the productivity in that region. If you recall the Tughlaqs, during the reign of Firoz Tughlaq, you basically had the construction of a canal system also, which happened around the region of Hisar in the present day area. Then, for example, so that is why, if you talk about the Eastern Gangas, if you talk about the Chalukyas, if you talk about the Cholas, all of them vied for the control of the eastern coastline. Nonetheless, you also had kingdoms, for example, the Cheras across the west, and you also had, which were the kingdoms of the west? The geniuses of history that we have here. Which were the kingdoms of Marathas? What? Okay. Marathas, my dear friend, came in much later. I'm talking about much, much earlier. Rashtrakutas, Rajputs. Okay, thank you. So basically, when we talk about that's it. I don't want to know anything more. If you are talking about Rajputs and Mughals, let it be. So basically, across the western coast, you had the entire struggle for the control of the western coast by the Cheras, by the Rashtrakutas, the Pratiharas. They basically vied for the control of the western coast, spreading all the way from here to here. And that was largely to control the trade, because western coast has always been ideally placed for the ships coming in, ideally placed for the ships coming in, right? So Even if you talk about the old Roman trading post, Muziris, etc., all of them, western coastline, many of them. So historically, for example, whenever you had any of the kingdom, for example, Rashtrakutas, Pratiharas, Cheras, etc., whosoever controlled the western coastline, they had the continuous supply of the best breed of horses, for example, that they would import at that point of time. Others did not have that kind of an advantage. And that gave them an advantage further on in terms of the war strategy and the area dominance eventually as well. So that is basically the advantage that these coastlines have. And I would suggest all of you, my dear friends, all the knowledgeable amongst you, do read history once more. Okay, please do read history once more. I think you would have read history from the portion of knowing the stories, that what are the important and interesting stories in history. But do read history, because if you are saying that across the western coast Rajputs were present and Mughals were present, then obviously I would basically be conveying this to Abhishek sir as soon as possible. As soon as we take a break, I will convey this to that. And you would have attended his sessions, I assume. So that is something that basically I would basically convey it to them. But do revise history. Now that you read history, try to analyze that why is it that the kingdoms behaved in a certain way? Why is it that the kingdoms went to war with only certain areas? What is it that they wanted to achieve? Was it the case that, okay, today is Saturday, tomorrow Sunday, I have nothing to do and I have a long weekend also, let's do one thing, let's declare a war on the other? No, it was also always strategic. So western coastline has always been strategic in the terms of the trade activities. Eastern coastline has always been advantageous for agricultural productivity. It is across the eastern coastline where even today, across the Coromandel coast, the Tamil Nadu coast, you basically have multiple crops of rice grown in the same year. Three crops of rice can be grown in the same year, right? Now, these coastlines, they are named differently basically because of the regions. So, here in the region of Gujarat and Maharashtra, northern part of Maharashtra, this coastline, where the western coast is the widest, this is what is also referred to as the Kutch and the Kathiawar coast. And Kathiawar coast. Fair enough. If you have not read history till now, the next time that you read history, do keep an eye out on these particular snippets and facts. Then you will be able to interrelate it in a beautiful manner. And then the concept that you will grab for either of the subjects will be much more everlasting. This is the Kutch and the Kathiawar coast. Here, the western coast is wider. Then, as you move further to the south, here, beyond this, in the region from almost to the south of Chiplun, Ratnagiri, etc., you come across the extent of the western coast where it is the narrowest. This is the Konkan coast, where you have the mighty Konkan railways, right? Some of the best cuisine also that you will find across the country does come from this area. And this is one of those areas where I would always advise you, ever if you get an opportunity to travel by rail, do travel by rail. Maybe after the rainy season, during these times, do travel by train in these areas, because you get to see the engineering marvel that Konkan Railways is. You get to see the details and the intricacies of the Western Ghats in its natural beauty. You get to see in many of the areas the layering which exists in the region of the Western Ghats, which is an indicator that the geological formations would have happened as a result of multiple such layerings, one on top of each other. In many of the areas, for example, around Ratnagiri, around the region, as you move in the Konkan coast, you will also find the presence of estuaries, where the seawater enters inwards and meets with the river water. So, beautiful natural landscape, some of the unparalleled natural landscape is something that you find here. Then, here in the region of Karnataka, Mangalore, Udupi coastline, etc. This is where it is known as the Kanara coast. Kanara coast. And then again, the coastline becomes wider. And this is your Malabar coast. This is the region of your Malabar coastline. Okay. Now, in the region of Malabar coastline, the region is low-lying. The region is not of a great elevation. The region is low-lying. So because the region is low-lying, in many of the areas, if you can think about it, if let's suppose this is the region, in many of the area, the seawater ventures inland. In these low-lying areas, the seawater ventures inland. And as the seawater ventures inland, it forms a pool of saline water, right? Here you have sea that enters inland, okay? Because it is a low-lying area, many of the times you might have a river, small river coming from here, but then the seawater has entered inland and the river is now entering here itself. So this is what is referred to as a backwater. Significantly present around the region, for example, if you go to Kovalam, near Trivandrum, again, very beautiful place, you will find that wide network of that salty backwater where the seawater has entered inland. Now, it is in these backwaters that you have the very famous boat race also carried on. Now, on these banks of this backwaters, you will find very dense vegetation of mangroves, different types of mangroves, different varieties of mangroves to be growing here. Right. Now, in the eastern coastline, you have the portion up till the Andhra coast that is named as Northern Sarkars. Northern Sarkars. And here, this is known as the Coromandel coast. Okay, that is your Coromandel coast. Even within this, the Odisha coastline that is known by a different name. The Odisha coastline within it is known as by the name Utkal coast. So you have that regional classification. Okay, so that is the case of the coastal plains and the features of the coastal plains. Backwater is basically where, let's suppose, if you consider this as the landmass, if this is the coastline, if the region is at a low elevation, if let's suppose the region is at a high elevation, so there will be distinction between sea and land. If the region is at a low elevation, what will happen? In certain areas, the river water or the sea water will come inland, isn't it? So as the sea water comes inland, it can spread inside, and that is what is basically a kind of a backwater. This is the sea, and here you have the saline seawater coming inland. Sometimes it can also be the area where small rivers are basically ideally would have entered into the sea. Earlier, you might have a situation where at one point of time in history, you would have small streams coming from here. But because it would be a low-lying area, seawater would have entered inland from here, spread all over that region, and you would have a large backwater getting created. So that is your backwater. Yes, it is also what is a lagoon. Okay. Estuaries are always formed at the mouth of the river. Backwater can be formed anywhere. Depending upon the low-lying region, backwater can be formed anywhere. They are different from estuaries. Okay. Now, then we will come to the features of these coastline. We'll take a break and then we will come back to it. and then we will continue it. So we'll take a break and we'll be back. We take a break for 15 minutes today, and then we'll be back and we'll continue. I hope we are aware that this Saturday we shall be having an extra session in the morning. So a notification will be sent out to you, as I have already announced. So a notification will be sent out to you. So on Saturday we'll have an extra session. Okay. So let's take a break and let's be back. Soil in coastal plain is generally always alluvial soil or sedimentary soil. A confirmation about the audio, please. Audio, I hope, is clear and available. Okay. Shyam, my dear friend, a very innocent question is what you have. Shyam, are we aware about what is a normal fault, what is a reverse fault, what is a graben and a horst? Are we aware of that? Or do we have no clue? Have we forgotten those portions of geography long time back? If you recall, if you try to recall, Shyam, in the case of when we were talking about the folding and faulting, see, when we're talking about the process of folding and faulting, we had discussed about the fact, for many of you, when I tell you these things, it is as if recalling something or some memory of the previous birth. So, no clue, whatever it is. So, here, whenever you have a normal fault, what happens? Across the fault plane, there is a kind of a fault plane. Across the fault plane, one portion comes down. So, here, what is the resultant landform which gets created? You recall vaguely something? Is your mind telling you that yes, somewhere in the previous birth, I had seen something very similar to this being taught in the morning? Do you recall this? The days were bright and shining when we talked about this. So, this is what you know as escarpment. Do you recall this? Right? Hogback topography is what? Hogback topography. When we talk about the Himalayan mountains, ideally the mountains should be like this, but the Himalayan region, because the Indian plate is proceeding with a greater speed, so here the Himalayan mountains are much more steeper in the southern slope and gentler in the northern slope. That is what is a hogback topography. Just because two things resemble in shape does not mean both of them are the same. When you have a chapati, chapati is also circular. Sun is also circular. Can a chapati that you eat for dinner and sun, can they be the same? Absolutely not. They are very, very different. Right? So just because things are having a similar shape does not mean they are the same. And hogback topography does not mean that it is similar to the west. When we say an escarpment, escarpment simply tells about a steep slope near the region of the fault. Is that clear now? Why Sri Lankan map come with Indian map always? As in, why Sri Lanka there? Sri Lanka has is also a landmass which has been created along with the Gondwana land itself, and it belongs to the same larger plate, the Indian plate. When we talk about it, includes that continental mass of Sri Lanka also. That is why, as the Indian plate has moved north, that portion has also moved north. Okay, it is said that a long time back you had a kind of a shelf area joining those two. If you observe, you have the case of shelf area joining those two. So there are theories which tell you that at one point of time these two had been connected, but due to the rise of sea level, you basically had water coming in between. That is the reason, as these were connected, that is the reason why you will have the similarity of vegetation, the similarity of even the animal species that you find across both sides. That is because you had a kind of a land connectivity with the rise of the sea level during the melting through the various ice ages. That is why water came in between. Can we say normal fault is related to subsidence of the landmass and reverse fault is related to upliftment? Absolutely, yes. Aditya, are the Western Ghats a type of a fold mountain? Aditya, my dear friend, I just now said Western Ghats are an escarpment. Escarpments are created due to formation of a fault. Am I not audible anymore? Is it the case that I'm not audible? Or is it that the sound of your keyboard is so high that you are unable to hear me out? Please listen to this carefully. The Western Ghats have been created as a result of the subsidence of the landmass. That is why you have the steeper western slopes, and that kind of a land feature is what is known as an escarpment. Kindly take a look at the annotations of the PPT for module 4. I understand that you would have kept it somewhere that when the stars and the sun, everything aligns, when it is a perfect day, that is the day I will pick it up for revision. Wait for that day. That day, whenever it comes, 2024, 25, 26, 27, whenever that day comes, pick up the module 4, the annotations of the PPT. You will find the mention of the term escarpment in the case of the normal faults. You will find the use of the term escarpment also. In the definition also, you'll find the use of the term escarpment. Okay, so Western Ghats are an example of an escarpment. Why southern portion of Western Ghats are higher in elevation than other portions of it? Very good. Satyam and Yogi, both of them simultaneously asking the same question. So it is the case when we talk about the southern part of it, there the western coast, Western Ghats is also very narrow. It is significantly narrower, but it has got a slightly higher elevation. That is simply because of the process of formation. As the process of formation happened, now in the southern part, you did not have the spread of that flood basaltic lava. Remember, the we talked about the fact that you had the Karnataka plateau getting created. Karnataka plateau was created as a result of volcanic eruption. Now, it was the southern part of the Western Ghats that you see, that is a resultant of those volcanic eruptions, what is also referred to as the andesitic volcanic eruption. I'm not going to go into the detail of andesitic eruption, not at all required. But that is the kind of an eruption which creates the continental land masses. So that is where you had these high elevated hills getting created. But when we talk about the northern parts of the Western Ghats, there you have the flood basalt which spread over. Flood basalt will never be able to gain an elevation as compared to those which have a kind of a volcanic mountain formation. Anywhere where you observe a shield volcano, for example, African shield, for example, in Africa, you have the Kapwal Craton. Now, there it won't have an elevation, but take a look at Kilimanjaro. Kilimanjaro is of volcanic origin, it has got a great height, right? So, in the region of the Karnataka plateau and further south of it, these were the portions created due to volcanic eruption and different type of volcanic eruption which accumulated in terms of its height. That is why you have greater elevation. But in the region, for example, in Maharashtra, Kutch Kathiawar coastline, because you had flood basalt which could spread so easily, that is why they never would gain an elevation. Is that understood? Right? Atharv, have you written the mail with your name itself? If not, uh, do send a reminder over that. We'll get back to you today itself. Right? And please don't have a timeline within generally I clear all the mails within 48 hours, but if it is not replied back to you in 48 hours, do send back a mail. And okay, then Chandrajyoti, you had a question, that is if at polar high precipitation is very less, then how glaciers at poles? By freezing. During the winters, there will be fresh freezing activities which will happen. And there, whatever moisture is present, it immediately will solidify into ice and snowpaths. That is why. Okay, right? I hope that is clear. Can we move ahead now? Okay. So, in the western coast, you have the situation which is ideal for the formation of ports and harbors. So here you will find many of the natural ports and harbors to be situated here. Kandla in the region of Gujarat, Masagaon docks, JLN port, Navasheva, Marmagao, Mangalore, Cochin. These are few of the important natural ports which are situated across the western coast. Now, based upon the region, western coast is divided into Kutch and Kathiawar coast, where it is slightly broader. It is the narrowest in the region of the Konkan coast, and it is again very wide in the region of the Malabar coast. That is where in the Malabar coast you have the backwaters, which also comes into existence, right? Backwaters, because of the low-lying areas, the seawater ventures inwards, and that is where you have these presence of these backwaters, where also you have the very famous boat race. And what is that famous trophy for which the boat race is conducted every year in the region of Kerala? One of the good spectacles that you can have when you visit Kerala. What is that famous trophy? Good. It is the Nehru Trophy, Nehru Cup. Good. So basically, that is where you have the backwaters, which are also known as kayals. Natural port and a human made port, the difference is very simple. See, in a region where we say natural port and harbors, means that in that area the terrain is such that it can allow the ships to come inland or right up till the coastline. So that is a condition suitable for a natural port. Naturally, that, for example, if you take a look at Muziris, right? Muziris, have we heard about the name Muziris? No? Okay. So Muziris is an ancient port across the western coastline, which was used by the Romans, right? And there you have evidences of trade going back to the Roman period. So Muziris, basically, that has been relevant many of the time for the portion of current affairs. Also, it is always in discussion. So Muziris, in those areas, you'll find the water is very deep, closer to the coastline. Now there, nowadays you cannot allow the, like in olden days, people simply to operate across the rocks. Now, even if in the natural port conditions you have to build the berths for the ships, you will do some construction. But take a look at, for example, the Ennore port or the Kamrajar port. Kamrajar port, which is one of the only major ports to be registered under the the Companies Act. Rest of them are registered under the Port Trust Act. The Kamrajar port is situated immediately to the north of Chennai. Now, for the construction of Kamrajar port, there was a requirement of continuous digging underwater to make that depth of water significantly large enough so that larger ships can be handled by them, right? For example, across the eastern coastline, Vishakhapatnam is one of those ports where naturally deep water is present. Tuticorin is another one of those where naturally some amount of deeper water is present. But in western coast, almost all the ports are there where naturally deeper waters are prevalent. That is why even when India is constructing the aircraft carriers, presently India has got two aircraft carriers. I hope we are aware of that. Now, both of them are berthed across the western coast, right? Aircraft carriers are large vessels, 45,000 tons of displacement. So basically, that aircraft carrier, both of them, one of them is generally, that is the Vikramaditya, is generally around Karwar coastline. Karwar port immediately to the south of Goa. If ever you happen to travel or visit by road around the region of Karwar, or Gokarna, immediately to the south of Goa, you will find that the ships are very, very close to the coastline, something that you never find across the eastern coast. But having said that, as India is planning to build the next aircraft carrier, or even if there is a deployment of the aircraft carrier Vikrant, it always happens only in Vishakhapatnam, which is the headquarters of the Eastern Naval Command. So it always happens only in Vishakhapatnam because Vishakhapatnam naturally is a deep water port. Other than that, the portion of eastern coast, you have very shallow water. So if you are constructing a port, you have to dig deeper. Okay. Right? Yes, Karwar, you would be aware of that. Western Ghats are hard rocky surface. That is why no okay. Are man-made ports good enough to natural ports? See, if you have enough money, You can build anything out there, but basically if you have a natural port, you don't have that much amount of periodic maintenance which needs to be carried out. For example, Kamarajar port does require a periodic maintenance where the port operations are shut, and that is when the Chennai port gets over flooded with lot of operations, because you need to carry out that digging, right? And it is that limitation of the Chennai port for which you had built the Kamarajar port. So if it is natural, it is much more beneficial. Okay. And okay. So western coastal plains are narrow in the middle and they get broader in the north and towards the south. Here, no delta formation takes place in the western coastline. Delta formation is not going to happen. Why is that the case? There are few reasons for this. And it is a very kind of a natural logic here, no rocket science involved. First of all, majority of the rivers of Peninsular Plateau, the Peninsular India, the larger rivers, basically deltas are formed when the rivers carry huge amount of deposits, huge amount of sediments, and at the mouth they start depositing those sediments, and that is when they form the deltas, isn't it? That is what is the delta formation. So when you talk about, let's suppose, the region of the peninsular India, you don't have it in any scope. You don't have the presence of large rivers draining to the west. Most of the rivers, they drain to the east. Okay, so most of the large rivers, almost all the large rivers, drain to the east, other than Narmada and Tapi. Large river systems drain to the east, right? Rather than draining to the west where they could have formed a delta. Secondly, amongst the rivers which drains to the west, you have Narmada and Tapi, and they flow through a rift valley. Now, what is a rift valley system? Rift valley system is where in the central portion you have a kind of a subsided land and you have elevated horse-like portions on both sides. Now, if the river drains through here, through the Rift Valley, that is where the Narmada and the Tapi moves. Now, this river will have a limited capacity to erode. Even laterally, it cannot erode much. Vertical erosion, can it carry out vertical erosion? No. Why? Because it is already flowing through a depressed area. When is it that the rivers carry vertical erosion? When they face an obstruction, they try to erode that. But what if a river is already flowing through a low-lying area in a depressed area? That tendency of vertical erosion will be absent. And then when it is flowing in a kind of a bounded area between the Rift Valley structure, that lateral erosion will also be very limited. That is why Narmada and Tapi, when they also drain through the region of the portion of Rift Valley system, they also are not able to carry enough sediments which can form delta. Narmada and Tapi draining through Rift Valley system are unable to carry enough sediments. Then, generally, you will observe for the formation of a delta, you need the rivers to have that slow pace for some amount of time. Wider region of the plains, in the areas where the rivers move through the plains for a wider area or for a longer duration, that is when they start depositing the material slowly and steadily. Now, in the eastern coast, you will find that there is a large eastern coastline where, as the rivers, they basically come closer to their lower course. That is when they have ample amount of time, ample amount of distance to carry out more erosion, and also start deposition. Western coastline is very narrow. Because the western coastline is very narrow, there is not enough scope to create humongous delta by these rivers. So western coastline is very narrow. Coastline is very narrow, not sufficient to form large deltas. Deltas. Okay. See, Akhilesh, when we talk about the rivers such as Mandavi, Mahi, Sabarmati, first of all, these are very seasonal. The flow in these rivers are very, very seasonal. During the dry seasons, when you go into this area, the flow is very limited, very less flow, right? But in the case of Sabarmati and Mahi, even furthermore, Mandvi still has got some amount of a regular flow because it moves through the region of the Western Ghats, and they're not very large enough, right? These are not very large rivers. See, why is delta getting created? Why are deltas formed? Whenever you will have, and we are talking about extensive deltas, large deltas. We are not talking about that, okay, in some area you had 1 kilometer, 1 square kilometer of deposit. That is not to be considered here. We are talking about large delta. For example, Krishna Godavari Delta, Mahanadi Delta, Kaveri Delta, Ganga Brahmaputra Delta. These are very large deltaic areas. Now, small rivers, they will never have enough sedimentary materials which can keep on getting accumulated and then form a delta thereby. Okay, so that is why in the western coastline, rather than deltas, you will only have estuary formation. So here, only estuary formation will be observed. Estuary formation is observed. Now, also, what do you think? Will there be an estuary formation across the eastern coastline also? Or in the eastern coastline, there won't be any estuary formation? What is your perception? Will there be an estuary formation in the eastern coastline? Yes or no? Good. It is there. In fact, because you have more number of rivers draining into the eastern coastline and in the eastern coastline many of the times will have larger number of estuaries as compared to the western coastline, many of the times. Okay, so estuaries are there both across eastern and western coastline, but deltas are going to be there mostly only across the eastern coastline of the country and not across the west. Now, the Malabar coast has got certain distinguishing features in the form of backwaters or kayals, which are used for fishing, inland navigation, and also due to its special attraction for tourists for the various boat races. And you have the various tourist destinations around the region of these backwaters, mangrove vegetation, etc., which are a specialty of this Malabar coastline. Now, when we talk about the eastern coastal plain, eastern coast is an emergent coast. It is an emergent coast. Western coast is a submergent coast. Eastern coast is an emergent coast. So when we talk about the eastern coast, which is an emergent coast, it is slightly broader. Now here well-developed deltas are formed. So when we say emergent means it has emerged slightly above water. So here formed by the east flowing rivers to the Bay of Bengal, deltas of Mahanadi, Godavari, Krishna, and Kaveri. They are, you will find, well developed deltas. This is known as the Coromandel coast in Tamil Nadu. This is known as the northern Sarkars, or rather Utkal coast in the region of Odisha. Here you will find very fertile sedimentary deposits, very fertile layer of the presence of sedimentary alluvial soil. So agriculturally, this region is very productive. So this is very productive agriculturally. Productive agriculturally. Okay. Now, after this, we come to the island groups. But before the island groups, or do we study about that after the island groups? Okay, we'll study it before the island groups only. So that is the question: why more frequent landslides? Landslides occur more frequently in Himalayas as compared to Western Ghats. Right. So, Shan, basically, this is a question which has been asked by UPSC multiple times. So, why is it that landslides occur they more frequently and they occur more repeatedly in the region of Himalayas as compared to the Western Ghats? Let me see. Steep slope, high altitude, tectonic activity is good. Folding of land, Himalayas are more steeper, good. Due to Western Ghats have rocky and forest, that's why. But Afrin, you are saying that Western Ghats have more landslides. Earthquake, tectonic zone, good. Shyam, because Himalayas are still developing, good. Sonia, rains, monsoon rainfall occurs in western coast also. Western Ghats also receives heavy rainfall due to earthquake. Okay. Formation of Himalayas by compressed cloudburst, good. Harika. Loose top, good. Shan. Young mountains, Shreya, good. They are young and full mountains. Western Ghats are stable, very good. Indo-Eurasian plate movement. Western disturbances. No, because Western disturbances occur in these months. So in these months, you don't observe much of the landslide. Uh, Sedimentary and loose base, good. Atharv, rock deformation, okay, right. Siberian winds, no, absolutely not. Steep topography, emergence of rivers, human pressure and earthworks, very good, very good. So if somehow I could make you guys all sit together in the examination, you would definitely clear the examination without any doubt. But let's say when we talk about the reasons for this, first of all, the region of Himalayas, these regions of Himalayas, they are unstable. They are the young areas, young mountains, which are unstable, where the folding is still happening. And due to the tectonic forces, there is high amount of seismicity. So here, Himalayas, unstable slope, still evolving, tectonic activities, earthquakes, these lead to slippage of rocks. No, subsoil is not frozen everywhere, Rishika. Then Western Ghats are old and stable landscape Yes, Kavita, that is also correct. Then lack of vegetation in Himalayas. In Himalayas, loose topsoil, whereas Western Ghats are very densely vegetated. Then, after that, you also have the condition where, when we talk about the regions of the Himalayas, here you will also have frequent cloudbursts of high intensity. Western Ghats also sometimes experiences cloudburst, but not that frequently. Himalayas, they experience it very frequently. Then after that, southern slope is very steep. In the case of the Himalayas, obviously, large number of rivers drain through the Himalayas. Of rivers drain through Himalayas, which destabilize the slope, which destabilize the slope. Then, in this case, frequent melting of ice enables movement across the slope. So, Rishika, that will be a better encapsulation across the slope. Okay. Sedimentary deposits are more in Himalayas. Okay. Then sediments are more means loose soil which is ready to flow. And Western Ghats, largely rocky substrate. And whatever soil is there, it is held by the plants. Then construction and mining activities. And mining activities in Himalayas have weakened the slope. Okay. Can we draw diagrams in this question? Absolutely. See, when you write the answer ideally for this particular question, do it in a bullet point format, and thereby after that each of these points should be elaborated a bit. This is a straightforward phrase that I have written, but it should be slightly elaborated for 2 to 3 sentences, and in a brief paragraph, point wise, bullet point after each one of them, give a gap wherever possible, draw the image. For example, even for that matter, you might think that for this simple thing, why do I need to draw the image for this? But even that is very helpful for sometimes. For example, availability of loose soil in the region of Himalayas and presence of dense forest in the region of Western Ghats means the soil will be bound together. Draw a kind of a tree and the loose soil and the tree binding it. That will also suffice. So draw and represent images wherever and whenever possible. So that is going to increase the heft of your answer. And this is a question that UPSC has been repeating for past decade and a half, and it is consistently being asked every 2 to 3 years. You will find this kind of a question, a rephrasing of this question, a reconceptualization of the same concept, but the question largely revolves around the same concept. That is something that you will find to be asked in the examination in the mains, both for GS and optional. UPSC is doing that. Okay, so that is basically the case of how to answer. Can we answer such questions in pointers only? Are we supposed to make diagrams? You are supposed to draw diagrams. Every question of geography will need a diagram. You need to provide a brief intro also, that this is the region, or the region of Himalayas along with the Western Ghats are the landslide prone regions across the country, but the frequency and the intensity of landslides is much highly exaggerated in the Himalayas as compared to the region of the Western Ghats. That is something that you can write in the intro. Now, the reason why the Himalayas experience so frequent landslides are, and then you can encapsulate it. Conclusion can be, now, or unsustainable developmental or tourism activities, that is why need to be brought under consideration, and that is why we need to rethink about our approach to deal with the critical Himalayan ecosystem, because that is critical for the support system of the rivers and the climatic system, which influences the lives of billion plus Indians. That's it. That is how you can conclude the answer. Okay. Now, after this, we come to the portion of the island groups. Now, when we talk about the islands, we do have the presence of islands both in the region of Indian Ocean also, in the region of Arabian Sea also, as well as in the region of Bay of Bengal. Now, both of them have different origin and different creation and different process of formation. When we talk about the island in the region of Arabian Sea, so that is Lakshadweep. Lakshadweep. Now, Lakshadweep is an island formed out of corals. So, it is coral islands. So, Lakshadweep, that is generally formed where you have had these seamounts across the entire Lakshadweep Maldivian ridge. So, there you have had these seamounts on which the corals have grown to form these coral islands, and a few of them are atolls as well. So that is why Lakshadweep are largely referred to as coral islands. But when we talk about Andaman and Nicobar, I hope we are aware that the only active volcano in India is the Barren Islands, which is situated in the region of Andaman Nicobar. So Andaman Nicobar, you will have the presence of volcanic islands. Volcanic islands. Now let's suppose you have this much information. You don't have any other information with you, but you have studied geomorphology. Let's assume this, that you have studied geomorphology carefully. Now, in that case, why do volcanic islands get created, or what is the process which leads to the formation of volcanic islands? What do you think? Ashish, Joshimat can be. Joshimat is a very different case, my dear friend. I'll tell you about Joshimat. Remind me after this island. We'll talk about Joshimat also for a bit. So, why is it that volcanic islands get created? Cooling of lava and lava flow, please have a better answer than that. Solidification of lava is how any but then solidification of lava would have happened over the Deccan traps also. Solidification of lava would have happened in the Chota Nagpur plateau also. How else will you have? How is it that islands get created? Good. It is basically mostly because of oceanic convergence, isn't it? Oceanic convergence that leads to the formation of volcanic islands. Guys, please revise. Otherwise, all this effort that you are putting in, effort in the sense that you are waking up early in the morning for the past month and almost a month, and you could have, early in the morning, you could have visited some place, you could have had a walk outside, you could have listened to good music, you could have watched a good movie, but you are sitting early in the morning and listening to issues about salinity, aspect about ocean temperature, coral reef, escarpment. It will be of no use if you are not revising. Let me be very articulate in that. It might, as of now, you might have shut down your ear that again he's saying something which is not relevant. But please remember this. 2 months down the line, when you pick up the same PPT, the same module, you will find yourself in a position that you won't be able to recall anything. Don't let that happen. Don't let your time go to waste, or else do something else in life. Please don't waste your time in this case. So oceanic convergence mostly leads to the formation of islands. Now, when we talk about the region of Andaman Nicobar, how is it that oceanic convergence would have happened? So basically, here, if I take you back to the map here, observe this particular portion. It is a kind of an arc-like feature, isn't it? It is like an arc. It extends furthermore around the region of Indonesia, Java, Sumatra also in the same shape. Andaman Nicobar is also said to be, in geographical terms, it is said to be the northernmost or the northern extension of the Indonesian arc. And Barren Island volcano is also referred to be the northernmost eruption of the Indonesian arc. Right, in the entire region to the west of Indonesia, you will find many of these volcanic eruption. You will find the presence of the trenches also in that area, Java Trench, Sunda Trench, etc. But here, which kind of convergence is taking place? So, Indian plate has got the oceanic crust of which is the region of Bay of Bengal. This is the oceanic crust. Now, this is the oceanic crust of the Burmese plate. Burmese plate is a minor plate, which is a minor plate which was earlier a part of the Eurasian plate. So Burmese plate is a minor subcontinent, a subcomponent of the Eurasian plate. So the convergence between the Indian plate and the Burmese plate means the oceanic crust of the Indian plate converges with the oceanic crust of the Burmese plate. That convergence with the Indian and the Burmese plate happens overland also. That is what leads to the formation of Arakan Yoma, Pegu Yoma ranges. Right, they are created due to fold. Even Patkai Bam, Naga, Lushai that you observe, that is a fold mountain. Why is that fold created? Why is that fold created across the east? Because you have the Indian plate and the convergence of the Burmese plate. Similarly, that convergence, when it happens in the case of the oceanic crust, that creates a series of these volcanoes. Many of the seamounts get created. In fact, here you also have a very, not very deep, but a narrower Andaman Trench is also to be found in this area. So here you will find the Barren Island volcano also is situated in this area. So that is the reason why you will find the formation of the Andaman Nicobar Islands. So when we talk about the formation here, Andaman Nicobar convergence of oceanic crust of Indian plate with the oceanic crust of minor Burmese plate, right? Creation of volcanic islands. Islands and seamounts. And also formation of minor Andaman Trench. Okay. So that is the entire process of formation. Now, here, when you talk about this formation and these Andaman Nicobar Islands, the relevance and the importance of Lakshadweep and Andaman Nicobar, we have already discussed yesterday when we talked about the fact that these are like an extension of India's strategic arm. Andaman Nicobar and Lakshadweep, that extends our reach further beyond the mainland. And in the region of Andaman Nicobar or in the region of Lakshadweep, you also have a huge potential for ecotourism. Other than the defense and the strategic advantage that I'm sure you will be able to write it out, other than that, the potential for ecotourism is very huge. Lakshadweep Islands, many of them have an absolute similar feature and a property as compared to Maldives, right? The islands of Maldives, they are very similar to Lakshadweep. On one hand, every year, Maldives churns out billions of dollars in revenue. The entire economy of Maldives is functioning entirely on the tourism sector. People from across the world, they want to visit Maldives. They do visit Maldives, particularly in this time of the year. Almost from people from every country, they will visit Maldives. If you think about it, you have in the region of Maldives, you have direct flight from Russia, from Turkey, from Dubai, from Singapore. So it is connected to the world. Why? Because tourists do visit that every year in large numbers. But look at Lakshadweep. Lakshadweep does not have a flight connectivity even from various parts of India. Lakshadweep has got a connectivity only from Kochi. So Lakshadweep, we are basically squandering the potential of Lakshadweep. The potential can be huge. The potential can be significant. But for that, what is required? A basic infrastructure building is required. You need to provide some basic desalination plants as they are coming up in certain area. You also need to provide infrastructure for airports, for jetties to have harbors in certain cases, ships that can come, cruise that can come into certain areas. The cruise vessels, they have started going there. But this is where the Lakshadweep developmental plan, they remember the kind of national agitation that went into place, that now the government is going to consume Lakshadweep. Now the region of Lakshadweep will be a kind of a waste dump yard now, because now Lakshadweep, they are trying to build infrastructure. But you can always have a kind of a sustainable development. You can always have a sustain. Now, Maldives, they have the coral reefs, right? There, in the initial stages of construction, yes, there was some issues which were created, which is the case. But after that, they have carried out the conservation in a perfectly good manner. In Lakshadweep, so much amount of protests were held, right? That Lakshadweep, now that plan had to be dropped. The government dropped that plan. But if tomorrow, this time in the, that is why, due to those protests, this time in the optional paper you had a question about the ecotourism potential of the region of islands, the Indian islands, the ecotourism potential of it. But tourists, they won't, do you think that a tourist, what they will do, they will take a boat from Kerala all the way, they will go to Lakshadweep because Lakshadweep is a good place to visit? No. Unless and until you provide them connectivity, unless and until you provide them with the basic necessities, even you won't go there. Why would you go there? Let's suppose you are from the region of Jammu Kashmir or the region of Rajasthan or from the region of Himachal Pradesh. Why would you go through all those loops and hurdles to reach an area where you might not have a water supply? If you get ill, you don't have the nearest hospital. The nearest hospital, you have to fly to Kochi to avail a good medical facility. Why would you go to such areas? You would never go. That is why Lakshadweep largely has been reduced to a very minute and a kind of not that great and important economic setup, where only the local fishermen, they are surviving there. Now, if let's suppose you carry out, and always remember, it has to be sustainable development. Development does not mean that you will destroy the ecosystem. Development has to be sustainable, and you have enough technology across the world to carry out sustainable development. Now, think about it. What is China doing in the region of South China Sea? It is propping up artificial islands. Why? because that will extend its strategic arm. Very soon, you will find China in the next decade or so, one or two artificial islands, it will also have people there. We have that naturally present. But then, Indian tourists, they make one of the heaviest footfalls across the globe, right? And for us Indian tourists, Lakshadweep is almost closed unless and until you are ready to pay a very heavy amount of price so that you can ride from a cruise to the nearest place or to the islands you can go for that island visit. For an average middle class citizen, these islands are virtually closed off because you don't have enough infrastructure. That is why this is an opportunity that India can exploit, can utilize. It has got very important ecotourism potential, very significant biodiversity, very cleaner waters. Now, think about it. All the big people, the well-off people, they can anyway, they can charter a private jet and they can reach there, but it is the middle class tourism sector that you have to attract. That is when there will be job creation in that area, there will be significant amount of revenue uptake in that area, and there will be long term benefit associated also. And for that, the administration needs to be very transparent. It needs to come out with a kind of a detailed plan also, that okay, this is what we are going to do. It had done that previously, but it met with a severe and serious kind of protest and a backlash. If you remember, the the administrator of Lakshadweep was even ousted from that area, right? Something very similar happened in the case of Virinium port also. But then obviously lot of change of money also happened, after which the protests, they subsided. Lot of promises were made, after which the protests subsided. Maybe we need to follow a similar approach, but we cannot have, see, the thing is, we cannot keep them as a kind of a museum, that we have an island there, nobody has visited that. There are not many people that I know around. Even you would know many people around you who would have actually visited the region of Lakshadweep. They might have visited Maldives, but they would not have visited Lakshadweep, which is equally beautiful. So think about it. That is an opportunity which is being squandered. Okay. Now, after this, we talk about these are the basic islands of Bay of Bengal and Arabian Sea. After this, we come to the portion of drainage system. Can oceanic divergent boundaries also lead to the formation of islands? Absolutely, yes, Animesh. And you are correct in that. For example, Iceland. Iceland is a formation of an island like island creation because of oceanic divergence. You are correct in that. Okay. Now, Joshimat, yes, you have talked about Joshimat. So, see, the problem with Joshimat is that Joshimat is not a kind of a area which is naturally present. So, in the region of Himalayas, there have been multiple massive landslides which have happened previously in the older days, ancient days. Multiple massive landslides have happened. Now, let's suppose you have these mighty mountains rising, very lofty, high mountains, as you would have seen in these areas. Now, if there is, let's suppose, a landslide of humongous proportion and continuous formation, now the materials will get accumulated here. The materials will get accumulated here. Now, even these materials, these are basically the outcome of these multiple landslides which have happened here. But when we talk about these materials, when we talk about, let's suppose, this area, now here, as the materials have come down, it is not always going to be the case that large rocks, first of all the large rocks stand in line, start sitting on the bottom, then medium rocks, now you come, it is not like a boarding for the aircraft, right? Or a school class. Basically, what has happened, and what generally happens in the case of the landslides also, is that on the lower surface, you have the sand and soil, loose soil and sand which is present, very loose soil, sand, etc. That is dominant in the lower surface. On top of this, you have large slabs of rocks which are present. Okay. On top of this, you have larger blocks of rocks which are present. Now, these rocks, over a period of time, the top portion of it has basically weathered in some portion to form the soil here also. But nonetheless, the reality remains that at the bottom of these large rocks, you have a kind of an unconsolidated deposit of soil. Now, what has happened over a period of time in the region of Joshimath? You have constructed significantly. You have constructed hotels. Look at the kind of hotels that have been constructed. The slope has been cut. There is a kind of a face of a hotel. The part of it is hidden in the hill. So you have these hotels, etc., which you build, various different construction activities that you carry out. Now, what will it do? What will this do? This will impose the weight, right? Imagine a situation where you have sand, on top of that, you have slabs of rocks. If you put weight on that rock, what will happen? The sand underneath, that is not very stable. Now, given the rainy season and the presence of rivers such as the Dholi Ganga stream, etc., from this area, now sometimes what happens is that you have multiple of these rivers draining through this area, right? Now, that further weakens the base. Now, as the allegation goes, NTPC never agrees to this, but as the allegation goes, there you have the Vishnugarh Tapovan NTPC project, Hydel project, run of the river project, which is going on. For that, there is that river which is moving, the region around Dholi Ganga, the river is moving. So, NTPC, what it has done is it had created a blockade in order to build for the dams. Now, building the blockade means what? That water slowly and steadily starts seeping. It seeps into this area. And during the rainy season, when already there is a high amount of rainfall, means the bottom soil is almost becoming fluidic in many of the cases. And on top of that, you have so much of weight. So, what will happen? It will straight away start to subside. From various weaker portions, the land simply gives way. That is the reason why subsidence is happening in Joshimath. It is not because of earthquake. It is not because it is a seismic zone. It is not because of any other reason. Joshimath is built on the deposit of an ancient landslide, unconsolidated deposit of an ancient landslide. So, as that unconsolidated deposit, which is not stable, as that gives way, the entire Joshimath is experiencing that subsidence. Okay, I hope now that is clear, right? I hope no doubt in that. Now, then we come to the portion of drainage systems. Now, here, as I have told you, the portions which are relevant, very basic one of them. When we come to the rivers of India, there you have other portions also which are relevant for your examination. So, basically, what is the solution to prevent the sinking of Joshimath? Stop that construction activity, reduce the population pressure from that area. Why do you need to have so much amount of hotels, tourist places in that area? That is where I talk about sustainable development. In Lakshadweep also, if you carry out wanton kind of an unsustained tourism and construction of these hotels, what will happen? And you know who benefits from this? Mostly it is the political class. If you talk about who has got maximum number of hotels, eventually you will trace it to some or the other politician, right? Same is the case with majority of the places. So that is why if you carry out for, and it is this political class which won't allow any new players to come in also. So that is where if you ensure that there is a master plan that only this much amount of capacity addition will be allowed, fair enough. That is more than sufficient. Okay. What about the minerals and energy resources in India? What about it, Mohan? They are good. Minerals are good. Energy resources are also present, not in great amount. Minerals are largely distributed in Chota Nagpur Plateau, Bastar Plateau, Karnataka Plateau, the region of Aravallis and Bundelkhand. And then the energy resources, the coal is present in the area around the Damodar River Valley, Godavari, Mahanadi, the older sedimentary formations. Oil is to be found in Krishna Godavari Basin, in the region of Ankleshwar oil fields in Gujarat, Bombay High in the region of Rajasthan. Okay, so that is about the mineral and energy resources. Kuraku, yes, that will be a good conclusion. Now, when we talk about drainage systems here, drainage, what is drainage? Whenever a topography comes into existence, whenever a new topography comes into existence, whatever excessive water is present, either by melting of ice and snow or by excessive concentrated rainfall in an area, that water starts to flow. That water starts to flow. It will flow in which direction? It will always follow the slope of the land, right? But that flow, how that flow has happened, how that flow has been initiated, is going to be dependent on the topography of the land. Let's suppose the land is having a hard igneous rock. The river won't be able to form very distinct meanders like this, right? But if the same river is moving through a alluvial soil or sedimentary soil like in the northern plains, they will be able to change their course, shift their movement, form these meanders, etc. That will be a very common feature, right? So like that, basically you will find that depending upon the topography, the flow is distinctly different. Okay, now here, when we talk about the drainage systems, here the flow of water through well-defined channel is known as drainage, and a network of such channel is the drainage system. Now, they are governed by the topography of the land, the gradient of the land, geological time period, how old is the land. If the land is older, there can be some erosion which can take place. If the rocks are harder, less erosion. If the rocks are the soft sedimentary rocks, for example, in the region of Andhra Pradesh, remember, while we were talking about the cratons, if I can take you back to that slide, if when we were talking about this, here you had the sedimentary deposit, so you have sedimentary formations here, sedimentary rocks. So here you can have easily the sedimentary rocks can be eroded, canyon like structures can be created, etc., right? So nature and structure of rocks, amount of water flowing, periodicity of the flow, all of that is going to determine the nature and the characteristic of the drainage system. Okay. Now, a river drains the water collected from a specific area, which is known as the catchment area. What does that mean? So, for example, let's suppose you observe a kind of a flow of a river which is flowing in a manner like this, right? So, it is not the case that only if it rains here, that river will be carrying water. No. When you generally observe this, let's suppose if you have a kind of a mountainous area or a hilly region, let's suppose. Now, if there is a river originating from here, right, the tributary of a river is coming from here, let's suppose. Now, even if it rains in this portion, the water will slowly and steadily go to the river. Even if it rains in this area, the water will slowly and steadily come to the same river. If let's suppose it rains here, it will get to the same river slowly and steadily with the help of a runoff. If let's suppose there is rainfall here or the groundwater comes to the surface here, it will have accumulation of water and this will also flow to the same river. So we can say that the river is basically getting water from all the surrounding regions. From all the surrounding regions, the river is getting that water, isn't it? So the water of the river is basically getting accumulated from all that area. So that will be the catchment area of the river. Okay, so catchment area is the larger area from where the river carries its water. So for example, if you observe this particular image, now here, if it rains here, if it rains here, anywhere, water will drain into the same river flow, right? So this is your catchment area of the river. Through that entire region, water is accumulated and then it eventually drains into the river system. So that is the catchment area of the river. Okay. Now, drainage basins, they are divided from each other by the topographical barriers, which we refer to as watershed, which is generally a boundary line separating one drainage basin from the other. So let's suppose you have a kind of a mountain range, somewhat like this. Let's suppose you have a kind of a mountain range, somewhat like this. Now, if it rains in this particular portion, chances are that the water from here might basically drain in a different direction. If it rains in this area, chances are that water would basically drain in this direction, right? So here you have a topographical barrier in the form of the hills, which is separating the, which is basically a boundary line separating one drainage basin to the next. Okay, so that is what is known as a watershed. So that is a topographical barrier, right, which separates two drainage basins. For example, if you take a look at, let's suppose the condition of river Indus and Ganga river system. For a considerable period of time, river Satluj, Ravi, Byas, and Yamuna and Ganga, they move in the same direction from northeast to southwest. But then you will observe the Ganga river system taking an eastward bend and the Indus river system moving further to the west into Pakistan. That is because of the region of Ambala. Ambala is situated at a slight elevation of around 300 meters, and that is where you have the divide, the topographical barrier, which separates the rivers moving from each other. For example, Ambala divide separates the Indus and Ganga river system. Western Ghats separate eastward and westward flowing rivers in Peninsula Plateau. In the Peninsula Plateau, the Western Ghats or the Sahyadris, they act as a kind of a water divide there also. Okay. Now, then after that, we come to the classification of the rivers or the streams. Now, streams here indicates the river flow itself. Now, always the river will follow the slope and always the river will adhere to the laws of gravity. You won't find a river which with a great struggle is moving from a low-lying area to the top of the Himalayas. That is never going to happen. River will always follow a slope. Having said that, sometimes if you take a look at a river, it appears to follow the slope. Sometimes it appears to defy the slope. Everywhere it is going to follow the laws of gravity, but it appears as if it is defying the slope. For example, if you take a look at river Indus. Now, river Indus originates in the region around Mansarovar Lake in the Kailash ranges. That is where river Indus originates. Now, from there, Indus, as it moves first of all in the direction of northwest, it cuts through the region of the Himalayas. It makes a cut through the region of the Himalayas. as it cuts through the region of the Himalayas. Now, then after that, it drains into India and then into Pakistan. But to think about it, how can a river make a cut through the massive mountain like a Himalaya? If there would have been a Himalayan range and the river would be draining there, generally, if there is a mountain, the river would get diverted. But the river is cutting through. So it appears as if it is defying the slope. In reality, it is not. In reality, there's a different phenomena altogether, that as the Himalayas were getting folded, the Indus would already be in existence. It would continue to erode the fold. All around it, the fold continued to increase, but the Indus continued to maintain its original course. So, based upon whether it appears to follow the slope of the land or whether it appears to defy the slope of the land, based on that, you have the classification into sequence streams and insequence streams. So, when we talk about sequence streams, they appear to follow the slope of the land. Follow the slope of land. Right? Insequent appears to defy. Again, appears, not in reality, but appears to defy the slope of land. Okay. Now here you have the subclassification as consequent and subsequent. Consequent. These are the streams which would have come into existence immediately after the topography got established. So let's suppose if I consider the same topography that we have seen earlier in the case of the catchment area, let's suppose this is the kind of a topography of the landmass anywhere. Okay, let's suppose. Now let's assume that this landmass has come into existence. Okay. Now you have a river system. Let's assume this is the landmass. Now, immediately after the formation of the landmass, you have the origin of a river system coming all the way from here, following the slope. So, it will always be following the slope, right? And it has come into establishment, it has come into existence as a consequence of what? As a resultant of basically the case of the establishment of the slope, the establishment of the river system. Right. The establishment of the slope has brought about that gravitational angle into place, and the river which has come into existence after that, maybe due to melting of ice or snow or any other factor, that is the main river, first river which has come into existence. This is what is known as the consequent stream. That consequent to the formation of the landmass, the river has come into existence and is following the slope of the land. Ganga, river Ganga, for example, is an example of this, right? So this is where it follows the slope of the land. So this is what is known as the consequent, or this is also what is known as the master stream, mainstream, or master consequent. Master stream or master consequent. Then, maybe simultaneously, or maybe after a few hundred years or after a few 100,000 years, another river has come into flow here. Let's suppose another river has developed here. Maybe at the same time, it might have developed, or maybe after some time. It is also following the slope of the river, but mostly it ends up joining the main river. Now, that is your subsequent, which has either come after the existence of the main river or has occurred simultaneously but has ended up joining the main river. That is what is your subsequent river stream. That is your subsequent. Example, let's suppose Yamuna. Okay, that can be referred to as subsequent. So Yamuna, Ganga, all of them, they are a part of, or they are examples of sequent streams. So here, this is the definition for you. Consequent streams are the streams whose course is a direct consequence of the original slope of the surface on which it developed. That is, the streams that follow the slope of the land over which they were originally to be formed. Subsequent streams are those which originate after the master consequent and follow the slope. However, the geographers over a period of time, they have argued that subsequent could have originated at the same time as the consequent, and they might have ended up joining the main river. So that is basically the aspect of subsequent streams. Then when we talk about insequent streams, insequent, they appear to defy the slope of the land. So they appear to move in a way which appears to contradict the slope or the direction of the slope of the land. So here you have two types, that is antecedent and superimposed. So when we say an antecedent, antecedent means what? Prior to an event occurring, right? So prior to an event, I have given you the example of Indus. Similarly, if you take a look at River Satluj also originates in the region around Lake Mansarovar in the Kailash ranges. It drains or cuts through the Himalayas, enters India through the region of the Shipkila Pass. Now, how is it that river would have cut through the mighty mountains? River Brahmaputra cuts through the Himalayas. River Kosi cuts through the Himalayas. How is it possible? It is only possible if they would have been in existence before the folding process, and they would have been draining in that area before the folding process. The folding of the surrounding land masses would have taken place, and the rivers would have maintained their original course. So here, if you take a look at it, antecedent streams, they predate the upliftment of an upland or a mountain across which they have maintained their present courses through continuous down cutting of the valleys. Okay, so that is basically the antecedent streams. So here, observe this. Let's suppose a river is flowing like this. Now, if there's a folding which is happening, the river will continue to erode its base, continue to maintain along its original path. But around it, there is no particular area, or there is no particular agent of nature which will erode the regions around it. That is why it appears that the river is basically cutting through it and is defying gravity. Example of this: can it be mentioned as a Barber region? Absolutely not. Example of this: you can think about River Indus, River Satluj, River Kosi, River Ghagra also. Then River Brahmaputra. Okay, these are your examples of antecedent river. Then we have what is the superimposed. Superimposed is something different and something very unique. When we talk about superimposed, before confusing you with the definition, here, when we talk about the superimposed drainage, what is the meaning of superimposed? Something that you put on top of anything, a pre-existing scenario on which you keep something else. Now, what is this concept of superimposed? So, this is basically in a case where you take a look at the river right now, and if you take a look at the movement of the river, the impact that it has on the landmass, and then you take a look at the base rock, the river is eroding in a manner which the base rocks would never have allowed. So that is where it appears as if the river has been superimposed on that area from somewhere else. But let me paint a clearer picture for you. Let's suppose I have a kind of a landmass here. which is made up of hard igneous metamorphic rocks. Suppose this is the landmass or the landform. Okay. Now, if I ask you that in this kind of a landform, what is the projected pattern in which, or most probable pattern in which the river can flow? Is this going to be along this way? I'll name it as 1. Is it going to be along this way? I'll name it as 2. Where is it that a river is most likely to flow? 1 or 2? Obviously, in the region of 2. Almost all of you will agree to that. That is in the region of 2, where you will find that the river could have moved in that area. If the river would have been in existence, it would have been moving from that area. But the river is not in existence as of now. This is just the landmass that is made up of igneous rocks, which are the hard rocks. Now the landform keeps on evolving. Let's suppose over a period of millions of years, there has been sedimentation over it, and there has been formation of a sedimentary rock pattern. So let's suppose if I draw this after millions of years as the land has evolved. Okay. This is the hard base rock. Now on top of it, there has been sedimentary deposit of a different manner. Let's suppose the sedimentary deposit has been somewhat like this. This is the sedimentary deposit which has happened, which has basically taken millions of years for formation, and then these deposits have happened. Let's suppose. Now, here you have the evolved landform. This is your hard igneous rock. And this is your soft sedimentary rock. Now, if I ask you, where is it that a river is more likely to flow? Is it more likely to flow over here? The earlier portion that you saw that the river would be more likely to flow here. Is it more likely to flow here? I'll name this as 1. Or is it more likely to flow in this region? That is 2. If the river comes into existence now, where is it more likely to flow? Always in the region here in the low-lying area, that is 2, right? I hope there is no doubt in that the river is more likely to be flowing in this particular area. Now, if the river is to flow in this particular region, why is it so? Because the landmass has evolved in such a manner. The landmass has basically evolved in such a manner that now the river which is flowing through there, that is the kind of an ideal landscape where the river is flowing. Had the base rocks been the condition, the river would not have flowed. If the river would have been in existence at this point of time, it would have never flowed from this particular location. But because there has been sedimentary deposit, and the sedimentary deposit is in such a way that there is a low-lying area there, river is flowing through there. Now, the river will carry out erosion. It will carry out vertical down cutting, vertical erosion. It will erode this. It will erode this further. At one point of time, the river will reach the hard base rocks. After that, will the river say that, no, this is the upfold of the base rock, so I won't erode here? No, The river will erode this, the river will erode this also. The entire region will be eroded. Right. So the uplying area of the base rock or the upfold of the base rock is also eroded by this river. Ideally, the upfolds, that is not where the river moves. But because on top of that you have the superimposition of another kind of rocky material, and then the river has come into existence, it will continue to erode even in the upfold areas. So that is what is superimposed drainage. Right? Now let me show you a kind of a much more refined image of this. So see, the base rock here has got a kind of an anticline. Ideally, anticlines are the areas on which the rivers will never flow. But because on top of that you have the softer rock deposits, the river is draining through that area. The river is draining through this area. River is going to erode these soft rocks, and then it reaches the anticline region of the hard rocks. But it erodes that also. Ideally, if only the base rocks would have been the determining factor, the river would always have moved through the low-lying areas of the hard rocks. But now it is moving over the anticline of these hard rocks. So it appears to be out of touch with the base rocks. The river drainage pattern and the drainage system appears to be out of sync with the base rock, and that is superimposed. So if you apply your logic, in which kind of landmass will it be found to be present? In very older land masses or in newly created land masses, where you will find the presence of these superimposed drainage? Beautiful. Always in very old land masses, where over a period of multiple hundreds of thousands and millions of years, that land mass has evolved to have a newer soft structure on top, which can allow for a different area for river movement. So that is your superimposed drainage, particularly to be found in the region around Chota Nagpur Plateau, for example. So when a river flowing over a softer rock stratum reaches the hard basal rocks, that is the hard base rocks, but continues to follow the slope of erosion, it continues to erode the hard rocks, it seems to have no relation with the hard rock bed. It seems to be having an independent movement as compared to the hard rock bed. This type of drainage is called superimposed drainage. Okay, the stream has enough erosive power that it cuts its way through any kind of bedrock, maintaining its former drainage pattern. Example, Chota Nagpur drainage. Chota Nagpur drainage. Okay, that is the example of this. Okay, this is something which you will find incredibly difficult. Damodar is a river which moves through the Rift Valley system. Damodar is a river which, just like Narmada, Damodar moves through a Rift Valley, right? So it is a different matter altogether. Okay. The name is Chota Nagpur based upon the Nagvanshis, who basically ruled that area a long time back. And that is from where the name came into existence. It has got nothing to do with the region of Nagpur, which is the general preconceived notion that that region of Nagpur, it is a small depiction of Nagpur, hence Chota. No, it is basically derived from the people who ruled there, and the clan, the Nagvanshis ruled there, and that is where the name came into existence. Okay, so that is how older rock. So see, when I say that this is in existence in the older rock systems, so basically you must have had an old ancient igneous metamorphic rock system which could have gotten created. On top of that, over a period of time, sedimentary deposits, etc., would have modified the landform, and that would have allowed the river to move into a place where the older rock would never have allowed it to move. So that is why this is the system found in very old land pattern. So now the drainage pattern, we'll talk about drainage pattern tomorrow, and then we will basically carry this forward into the river systems of India. Tomorrow we'll also be talking about the floods in the Himalayan rivers, why the floods happen, why is it that the shifting of the river channel happens. And we shall also be moving on into the forests, right? The forests of India, the basic properties and the classification. That will be all for today. We'll take a few questions. Antecedent is basically when you have, let's suppose, a river which is draining and then the land gets folded. So the river will continue to maintain its original position, just like the concept that we studied in the case of incised meanders, if you remember, that all around it, as the land was getting uplifted, the river would continue its original path, and that would create a kind of an incised meander like structure. Okay, so that is antecedent. If you take a look at it, so here, let's suppose the river is draining, and then as the land gets folded, river would erode everything on its path. But in these areas, there is nothing to, no agent of nature which can erode these. So that is why this will continue to get uplifted, and that is the antecedent. Vishwas repetitions, multiple repetitions. Multiple repetitions are the only way to go. And then master consequent. Master consequent basically is the original or the main river which would have come into existence immediately after the slope has evolved or the slope has come into existence. That is the master consequent. And example of antecedent, my dear friend, these are the examples of antecedent that I have given. And then funny. We studied that crude oil is found in Rajasthan because it was underwater. That why crude oil found in Assam? Good question. Even in Assam, as I told you, that I did not emphasize on it much, but basically, as the Indian plate did collide and the folding had started to happen, you had the entire system of Indo-Brahm rivers accumulating the water in the present day region of the plains. It was not very significant amount of water deposit, but in the regions of Assam where Brahmaputra has got mighty flow, a kind of a shallow water body was created. And that is one of the reasons why you will find the presence of oil in that. It is because of that concept where even today you have many people trying to explore whether there is crude oil, possibility of crude oil to be found in other areas of northern plains where also water would have accumulated. It is only after the development of the Malda Gap that both the rivers of Ganga, Brahmaputra, they started draining into Arabian Sea, but into the region of Bay of Bengal. But before that, they were accumulating the water there for a substantial amount of time in the four deep region. That is one of the reasons why you have the marine species also evolving in that area. Okay. And basically, that was the region which was again low lying and the northern edge of the Indian plate as it was moving. So it was underwater, anyways. And as the Tethyan sea floor was getting compressed, that Tethyan sea water came inwards. So, for a considerable period of time, the edges of the northeastern edges they were underwater. So, that is why you have the oil there. Okay. Geeta, how can loose soil be present under large rock? Why can't they be present, my dear friend? Think about it. From a mountain, rocks are falling and the soil is falling. Will it be the case that always the first of all, large rocks will get deposited, then loose soil will get dropped from above? Whenever you have landslide, what happens in the case of landslide? In the case of landslide, whatever materials are free to move, they move. So it might happen that in today's landslide, you have only topsoil which falls. In landslide which happens 10,000 years later, you have some larger rocks which fall. In landslide which happens another 5,000 years later, you can have another loose soil which falls. So that is what is referred to as unconsolidated deposit. Please don't compare it to the ground soil that you find. Joshimath is not the case of the natural. For example, if you consider the region of Lucknow, if you consider the region of Delhi, etc., where base rocks on top of that partially weathered rock, on top of that slightly small weathered rock, then subsoil, then topsoil. No, here Joshimath is a result of the deposit of a landslide. So from the mountains, as the materials would have fallen down, that is where, first of all, what falls down. If, let's suppose, you consider this, if you consider this as a mountain slope, first of all, if the landslide occurs, here you have the rocks, what will fall down first? Will these rocks start falling down first, that no, no, I have to settle down at the bottom so that you guys can have a good, jolly good time? So, first of all, let me go. Will that happen like that? Does it happen like that? No, first of all, this soil will drop. In the case of the landslide, first this soil will drop. So, this soil will get deposited. Then, after that, over a period of time, then the large rocks can fall. Then, those large rocks can get on top of that. Right, that is the condition. That is the reason why it is referred to as a kind of an unconsolidated deposit. You told that more cyclone occurs in Bay of Bengal due to ocean stratification. Ocean stratification, Chandrajyoti, is only one of the reasons. There are multiple such reasons. We have discussed over a period of time that, for example, you have downwelling in the region of Bay of Bengal. For example, due to the trade winds, you have downwelling in the region of Bay of Bengal. Then, during the neutral and the negative phase of IOD, more occurrences of cyclone in the Bay of Bengal, because it is enclosed by land masses. It is much more closed area as compared to Arabian Sea, so it gets more heated up. Under the normal Walker cycle and under the conditions of La Nina, there are chances of cyclones in Bay of Bengal. So there are multiple such reasons why cyclones can develop over Bay of Bengal. It is not the case that all these factors have to come together. Any of these factors can be at play and lead to formation of cyclones. Satyam, for superimposed drainage, river needs to be in a youthful stage. So how they are formed near the Chota Nagpur Plateau has got many rivers. In the Plateau region will have many of the rivers. In the Peninsular Plateau, you will have many of the rivers which originate from a hill, etc., and then they drain down. There are, for example, if you talk about any of the peninsular river systems, they originate in the peninsular part. They don't originate from the Himalayas, right? So they originate from the small hills and mountains, and they move over. Okay, so that is the case. Okay, so we meet again tomorrow when we continue further. Till that point, do take care of yourself. Goodbye. Thank you. And we are meeting again on Saturday. So Saturday we are going to have an extra class. You will be notified about the timing also.